What if everything you thought you knew about reality is merely the surface of something far deeper and more mysterious? Picture time not as a linear river flowing from past to future, but as a vast ocean where every moment exists simultaneously. Envision space not as empty darkness, but as a vibrant field humming with hidden dimensions and unseen energies. And consider consciousness not as something trapped inside our skulls, but as a fundamental force woven into the very fabric of the cosmos itself. These are not just poetic ideas, they are serious theories emerging from the cutting edge of physics, philosophy, and cognitive science, challenging our most basic assumptions about existence. Today, we embark on an extraordinary journey through 40 mind-expanding theories that explore the profound connections between time, space, and consciousness. We'll venture into territories where science meets spirituality, where mathematics dances with metaphysics, and where the boundaries between the known and unknown become beautifully blurred. From the holographic principle suggesting our universe might be a projection, to the radical idea that consciousness itself could be the foundation of reality, we'll explore concepts that might sound like science fiction, but are being seriously considered by brilliant minds across multiple disciplines. This isn't just abstract speculation. These ideas have the potential to reshape everything from technology to our understanding of what it means to be human. As we dive into these futuristic theories, prepare to have your perspective stretched in ways you never imagined. We'll examine how time might be an illusion created by our minds, how multiple universes could exist alongside our own, and how consciousness might actually influence the physical world around us. This journey will take us from the microscopic realm of quantum particles to the vast expanse of cosmic structures, always returning to that fundamental question: what is the true nature of reality? By the end of our exploration, you'll have encountered ideas that could fundamentally alter how you see yourself and your place in the cosmos, leaving you with a renewed sense of wonder about the incredible mystery we're all part of. What if the steady tick of the clock and the undeniable feeling of moments passing are nothing more than an elaborate trick of the mind? This isn't just a philosophical musing, it's a serious proposition gaining traction in theoretical physics. The very flow of time, that river carrying us from yesterday to tomorrow, might be a powerful, persistent illusion generated by our consciousness to make sense of the world. Think about it for a moment. We never actually experience time directly. We experience change. We see a seed grow into a tree. We feel our bodies age. We watch the sun move across the sky. Our brains take this constant, cascading sequence of changes and weave it into a coherent narrative we call the passage of time. Physicist Julian Barber offers a radical perspective, suggesting that time isn't a fundamental building block of the universe at all. Instead, he proposes that time is emergent. It arises from the relationships between events, a secondary property that only appears when you have a complex system of interconnected things. In this view, the universe isn't happening in time. It's just a vast collection of every possible configuration of particles, every now. Our conscious journey from one now to the next is what creates the sensation of temporal flow. This aligns with the block universe theory, a concept stemming from Einstein's relativity, which paints a picture where the past, present, and future all exist simultaneously. The entire history of the cosmos is just a static, four-dimensional block, a frozen tapestry where your birth, your life, and everything that will ever happen are all equally real and permanent. From this God's eye view, there is no special now. We are simply consciousness moving along the world line, experiencing one slice of the block at a time, much like a needle reading the grooves on a vinyl record, believing the music is being created in that moment when the entire song is already etched into the disc. This leads us to a profound question. If the block universe is true and all moments exist at once, what creates the arrow of time? Why do we remember the past and not the future? This is where consciousness itself may play the starring role. Physicist Carlo Rovelli has suggested that without an observer, the concept of time loses its direction. At the most fundamental quantum level, time might be symmetrical. It's our act of observation, our interaction with the world, that introduces the asymmetry we experience. Our brains are prediction engines, constantly taking in sensory data and constructing a model of reality that has a clear past and a probable future. This process creates the arrow. It's akin to watching a film. The movie reel itself contains every frame at once, but it only makes sense to us when projected in a specific sequence. Our perception is the projector, creating the flow from a static set of information. Even our most precise measurements are beginning to challenge the classical view of time. Experiments in quantum time dilation show that time can flow at different rates, not just due to gravity and velocity, as Einstein showed, but also based on the quantum state of a particle. This hints at a reality where time is far more fluid and less absolute than our everyday experience suggests. So if time is indeed a construct of our minds, what does that mean for concepts we hold dear like free will? If the future is already out there, fixed in the block, are our choices an illusion? Or does our conscious observation somehow play a part in determining which possibilities become reality? This reevaluation of time doesn't diminish our experience, it deepens the mystery, forcing us to consider that the mind and the cosmos are far more deeply intertwined than we ever imagined, setting the stage for even more incredible connections between consciousness and the fabric of reality. Now, if time itself might be a construct of our perception, what does that say about the very thing doing the perceiving? This brings us to one of the most profound and radical ideas at the frontier of science and philosophy: the possibility that consciousness is not something produced by the brain, but is instead a fundamental feature of the universe, as basic and irreducible as space and time themselves. We're so accustomed to the materialist view that the brain generates consciousness, like a generator producing electricity, that we rarely stop to consider the alternative. What if that's entirely backward? What if consciousness is the fundamental ground of all being, and the physical world, including our brains, is merely a manifestation of it? This perspective, known as idealism, is championed by contemporary thinkers like philosopher and computer scientist Bernardo Kastrup. He argues that reality is fundamentally mental. In this view, the universe is one vast, interconnected consciousness, and what we perceive as the physical, objective world is simply the shared dream or appearance within this universal mind. Our individual consciousnesses are not separate, isolated entities, but rather dissociated alters of this one cosmic consciousness, much like how a person with dissociative identity disorder can host multiple distinct personalities. This elegantly sidesteps the infamous hard problem of consciousness, the question of how subjective experience arises from inert matter. If consciousness is primary, then it doesn't arise, it was always there to begin with. A related but distinct theory that is gaining serious traction is Panpsychism. This is the view that consciousness, or at least some rudimentary form of experience, is a ubiquitous property of matter. It's not that a rock is conscious in the same way a human is, but perhaps it possesses an infinitesimal amount of inner subjectivity, a faint mentality. In this model, the fundamental building blocks of reality, perhaps electrons or quarks, have a tiny bit of consciousness associated with them. When these particles combine into increasingly complex systems, like the human brain, these micro-experiences combine to form the rich, complex stream of consciousness we all enjoy. Proponents argue this is a more elegant solution than claiming consciousness magically appears at some arbitrary level of biological complexity. The most compelling hints for this radical shift in thinking come from the bizarre world of quantum physics. The classic double-slit experiment has baffled scientists for decades. When you shoot particles like electrons at a barrier with two slits, they behave like waves and create an interference pattern on the back screen. But if you place a detector at the slits to observe which slit each electron goes through, the wave-like behavior vanishes and the electrons behave like discrete particles. The very act of measurement, of observation, seems to collapse the wave function and determine the particle state. This has led some prominent physicists, like John von Neumann and Eugene Wigner, to propose that the conscious mind of the observer is the crucial factor in this collapse, suggesting an inextricable link between mind and the manifestation of matter. Beyond the laboratory, countless personal anecdotes and altered states of consciousness point toward this universal quality. Individuals who have had near-death experiences often report a feeling of merging with an infinite, loving consciousness, a state of limitless awareness unconstrained by the brain. Advanced meditators, through deep practice, can reach states where the sense of an individual self dissolves into a boundless, unified field of pure awareness. These aren't just fleeting feelings, they are consistent, profound experiences that suggest our normal, waking consciousness is just a filtered, limited version of a much vaster reality. If consciousness is indeed fundamental and universal, it raises an astonishing possibility that we are not just passive observers in a dead, mechanical universe, but active participants in a living, aware cosmos. Could we learn to communicate with this larger consciousness, to listen to it, or even to influence it through our own intentions? This shifts our entire understanding from a cold, accidental cosmos to one that is alive, intelligent, and deeply interconnected. So if consciousness is indeed a fundamental property woven into the cosmos, how then do we explain the solid, tangible world we experience every day? This brings us to one of the most astonishing theories in modern physics, a concept so strange it seems to leap from the pages of science fiction, the holographic principle. This mind-bending idea proposes that our seemingly three-dimensional universe, with all its depth and volume, might actually be a fantastically detailed projection, a cosmic illusion encoded on a distant, two-dimensional surface. Everything you see, feel, and experience, from the vastness of a galaxy to the warmth of sunlight, could be akin to an incredibly sophisticated hologram. The origins of this radical notion come from a seemingly unrelated puzzle, the physics of black holes. When a star collapses into a black hole, according to Einstein's general relativity, it forms a point of infinite density called a singularity, shrouded by an event horizon from which not even light can escape. But this creates a huge problem for quantum mechanics, which holds that information, the specific arrangement of particles that made up the star, can never be truly destroyed. So what happens to all that information when it falls into a black hole? This is the famous black hole information paradox. Physicists Gerard T. Hooft and Leonard Susskind made a revolutionary proposal to solve this. They suggested that all the information about every particle that falls into a black hole isn't lost inside the singularity. Instead, it is perfectly encoded and preserved on the black hole's event horizon, its two-dimensional boundary. It's like taking a three-dimensional object and flawlessly imprinting all the data needed to describe it onto its own surface. Susskind and T. Hooft then took a breathtaking leap, arguing that this principle might not be limited to black holes. Perhaps the entire universe operates by the same rules. Our cosmos, with its 3 spatial dimensions, could be a holographic projection of information stored on a vast, remote 2-dimensional surface at the very edge of the observable universe. Think of it like the hologram on a credit card. That shimmering, 3-dimensional eagle or globe isn't really there with volume. It's an optical illusion created by laser light interacting with precise patterns etched onto a flat, 2-dimensional film. In the same way, our brains interpret a flux of data from the cosmic boundary as a rich, 3-dimensional reality. This has staggering implications for the nature of space and time themselves. If the universe is a projection, then space isn't fundamentally real in the way we think. The distance between stars, the emptiness between atoms, the feeling of volume, these are all emergent properties, a rendered output from a deeper, more fundamental layer of information. Time, too, might be part of this projection. The physicist David Bohm presaged this idea with his concept of an implicate order. He suggested that the tangible world we perceive, which he called the explicate order, is just an unfolded, visible expression of a deeper, enfolded reality where everything is interconnected and whole. The holographic principle gives a potential physical mechanism for Bohm's philosophy. Our minds are the projectors, actively interpreting and decoding this holographic data stream into the coherent, consistent world we navigate. This places consciousness back at the center of the equation, not as a passive observer but as an integral participant in the translation of information into experience. It raises a profound and almost mystical question. If our reality is a magnificent projection, then what or who is the original source? Are we, in some way, both the audience and the projector, collectively dreaming a universe into being from a flat sea of data at the edge of everything? This theory doesn't just blur the line between the physical and the informational, it suggests they might be one and the same. But if our reality is a projection, a cosmic hologram emerging from a 2-dimensional boundary, where does that boundary even exist and what lies beyond it? This line of thinking naturally propels us into one of the most expansive and awe-inspiring concepts in all of cosmology, the multiverse. The idea that our entire universe, with its hundreds of billions of galaxies, might be just a single bubble in a frothing sea of infinite universes, each with its own unique laws of physics, its own history, and perhaps even its own version of you. This isn't merely speculative fiction. It's a serious theoretical framework that emerges from several independent branches of modern physics, each pointing toward a reality of literally unimaginable scale. One of the strongest pillars supporting the multiverse comes from the theory of cosmic inflation. This is the idea that a fraction of a second after the Big Bang, the fabric of spacetime itself underwent a period of hyper-expansion, blowing up by an enormous factor in an infinitesimally short time. While the majority of this inflationary field decayed into the hot plasma of our Big Bang, the theory suggests that inflation is eternal. In different regions of this inflating spacetime, the process stops at different times, each time creating a separate, isolated bubble universe. Our entire cosmos is just one such bubble in an endless, ever-expanding multiverse. In this eternal inflation scenario, the laws of physics could be set randomly in each bubble as the inflationary field decays. Some universes might have stronger gravity, making stars burn out in an instant. Others might have no nuclear force, so atoms never form. We just happen to live in one of the rare bubbles where the constants are perfectly fine-tuned for life, a concept known as the Anthropic Principle. Then there is the breathtaking landscape predicted by string theory. To make the mathematics of string theory work, physicists need extra spatial dimensions, usually 10 or 11. These dimensions are thought to be compactified, curled up into shapes too small for us to perceive, but the specific way they are curled up determines the fundamental laws of physics in that universe, like how folding a piece of paper in different ways changes its properties. The number of possible ways these dimensions can be compactified is staggering, estimated to be around 10 to the power of 500. That's a 1 followed by 500 zeros. Each possibility corresponds to a different universe with a different set of physical laws. This string theory landscape presents a vast multiverse of possibilities, and our universe is just one specific point in this colossal landscape of potential realities. Perhaps the most intimate and mind-bending version of the multiverse comes not from cosmology but from quantum mechanics, the many worlds interpretation. Proposed by Hugh Everett in the 1950s, it offers a radical solution to the strange problem of quantum superposition. In the classic Schrödinger's cat thought experiment, a cat in a box is both alive and dead until someone opens the box and observes it. The Copenhagen interpretation says the act of observation collapses the wave function, forcing the cat into one state, but Everett said there is no collapse. Instead, at the moment of observation, the entire universe splits into two branches. In one branch, an observer finds a live cat and experiences that reality. In another, completely separate branch, an identical observer finds a dead cat. Every quantum event with multiple possible outcomes causes the world to branch, creating a constantly proliferating tree of parallel universes where every possible outcome is realized somewhere. In this view, there is a universe where you never watched this video, and another where you are already a subscriber. There is a universe where the dinosaurs weren't wiped out by an asteroid, and another where humans never evolved. This is where consciousness re-enters the picture in a profound way. If the many worlds interpretation is correct, then every conscious observation you make isn't a collapse but a branching point. Your stream of consciousness is just one path winding its way through an infinite dimensional tree of possibilities. You are constantly splitting into countless versions of yourself, each one experiencing a different timeline. This raises dizzying questions about identity and choice. If every possible decision is made in some branch, does free will have any meaning? Or is our feeling of making a choice simply our conscious awareness following one path, while other versions of us follow the alternatives? The philosopher Max Tegmark has categorized these multiverse theories into different levels, from the simple idea of regions beyond our cosmic horizon to the ultimate mathematical universe, which proposes that every mathematically consistent structure actually exists as a physical reality. The sheer scale of these ideas challenges our deepest notions of uniqueness and destiny. If an infinite number of you exist across an infinite number of universes, it transforms the human experience from a single, linear narrative into a vast, branching tapestry of existence, where nothing is truly lost and every possibility is forever realized. While the multiverse suggests an infinity of parallel paths branching from every choice, another fascinating concept in physics proposes that time might not branch at all, but instead curve back upon itself, creating loops where the future and the past become one. This isn't just a fantasy. It's a mathematical possibility arising directly from Einstein's theory of general relativity. The equations allow for bizarre spacetime geometries known as closed time-like curves. Think of spacetime not as a straight highway from past to future, but as a roller coaster track that twists and turns, with a section that loops back to an earlier point on the ride. If you could travel along such a curve, you would, from your perspective, be moving forward in time. but you would eventually return to a point in your own past, effectively becoming a time traveler. One of the first to discover this potential within Einstein's work was the brilliant logician and mathematician Kurt Gödel. In the 1940s, he found a solution to the equations of general relativity that described a rotating universe. In this spinning cosmos, the entire fabric of spacetime is dragged around, and Gödel showed that this rotation could create closed time-like curves. In his model, if you traveled on a long enough journey away from Earth and then back again, you could potentially arrive before you even left. While we don't live in a universe that appears to be rotating in the way Gödel described, his work was a monumental proof of concept. It demonstrated that time travel to the past isn't automatically forbidden by the laws of physics. It's a feature that certain configurations of matter and energy can produce. Other theoretical constructs, like the infinitely long, rotating cylinder proposed by physicist Frank Tipler or the bizarre geometry around a ring of spinning black holes, also open the door to these temporal loops, suggesting that the universe's toolkit is far stranger than we imagined. Of course, the moment you entertain the idea of traveling to the past, you immediately run into the infamous grandfather paradox. What if you went back in time and prevented your own grandfather from meeting your grandmother? This would mean you were never born, which would make it impossible for you to travel back in time to stop the meeting in the first place. It's a logical contradiction that seems to make time travel an impossibility. But physicists and philosophers have proposed several clever ways to resolve this. One is the principle of self-consistency, championed by physicist Igor Novikov. He argued that the laws of physics would simply not allow any action that creates a paradox. If you tried to shoot your grandfather, the gun would jam, you would miss, or some other unforeseen event would always intervene to preserve the timeline exactly as it always was. In this view, free will on a cosmic scale is an illusion. Every action you take in the past was always a part of history, and you were always destined to travel back and play your role without changing a thing. Your journey isn't an alteration of the timeline, it is the timeline. Another compelling resolution comes from linking this idea back to the multiverse. Perhaps when you travel to the past, you aren't traveling back into your own original timeline, but branching off into a new, parallel universe that is identical to your past up until the moment you arrive. In this new branch, your actions can have any consequence. You could prevent your grandfather from meeting your grandmother, and in that new reality, a version of you would never be born. But that's okay, because you originated from the original timeline, which remains untouched and paradox-free. Your consciousness simply jumped tracks, leaving one universe behind and entering another. This idea was beautifully visualized in films like Interstellar, where the protagonist navigates a higher dimensional tesseract that allows him to perceive and interact with different moments in time as physical spaces, influencing events across history in a self-consistent way. This leads us to a profound psychological question. How would our consciousness even experience such a loop? If you were trapped in a period of time that repeated itself, like the classic film Groundhog Day, would you retain your memories each cycle? Some theorists speculate that certain unexplained mental phenomena, like the powerful sense of déjà vu, the feeling that you've experienced a moment before, or flashes of precognition, could be faint, subconscious glimpses of these nonlinear time structures. Perhaps in those brief instances, our consciousness brushes against a deeper layer of reality where time is not a straight line, giving us an intuitive, if confusing, peek at the true nature of the cosmos. If closed time-like curves are possible, even in theory, they force us to confront the very nature of causality and destiny. Is the future truly open, or is everything, including our attempt to change it, already written into the eternal fabric of space-time? This interplay doesn't just stretch our imagination, it challenges the core of our understanding of reality, freedom, and our place within the cosmic order. Yet if our reality can loop and curve in such impossible ways, what if the entire structure of our existence is not a fundamental property of the universe at all, but something far more artificial? This leads us to one of the most provocative and widely debated ideas of the 21st century, the simulation hypothesis. The core proposal is as staggering as it is simple. What we perceive as reality might not be base reality, but an incredibly sophisticated, computer-generated simulation, much like an ultra-advanced video game, created by a civilization far more technologically advanced than our own. While this sounds like the plot of a science fiction film, the argument has deep philosophical roots and is now being seriously considered by technologists, physicists, and philosophers. The foundational thought experiment goes back centuries to René Descartes, the 17th century philosopher who pondered how we can truly know anything is real. He imagined a malevolent, evil demon of utmost power and cunning who employs all his energies to deceive him. Descartes speculated that even the sky, the air, the earth, colors, shapes, sounds, and all external things could be mere illusions and deceptions this demon uses to ensnare his judgment. This is the classic brain in a vat scenario, updated for the modern age. Instead of an evil demon, we might be brains in a vat fed electrical signals by a supercomputer that generates a perfectly coherent virtual world for our consciousness to inhabit. The experience would be indistinguishable from what we call real life. The hypothesis was thrust into modern popular discourse by philosopher Nick Bostrom of Oxford University. In 2003, he formalized a trilemma, a logical argument with three possible conclusions, one of which must be true. His reasoning is deceptively straightforward. First, he assumes it is ultimately possible for an advanced civilization to create vast, realistic simulations of conscious beings, perhaps by harnessing the computing power of planetary masses or even stars. Given that assumption, Bostrom argues that at least one of the following propositions must be true. 1. Almost all civilizations at our level of development go extinct before becoming technologically mature enough to create such simulations. 2. Almost all technologically mature civilizations lose interest in creating such simulations. Or 3. We are almost certainly living in a computer simulation. Think about the sheer number of potential simulated realities. If even one advanced civilization avoids extinction and develops a fascination with running ancestor simulations to study its history, it could create astronomical numbers of simulated worlds, each populated with billions of conscious simulated beings. The number of simulated minds could vastly outnumber the one base reality. Therefore, statistically, any randomly selected conscious being, like you or me, is far more likely to be one of those simulated entities than a biological being in the original civilization. But is there any potential evidence, any glitches in the matrix that might hint at this being true? Some proponents point to the bizarre nature of quantum mechanics. At the smallest scales, reality appears to be pixelated, not smooth. Energy comes in discrete packets called quanta, and spacetime itself may be composed of tiny, fundamental units at the Planck scale. This could be interpreted as evidence of a resolution limit, much like the pixels on a screen. If you zoom in far enough on a digital image, you eventually see the individual pixels that construct the illusion of a continuous picture. Furthermore, our universe seems to be built on mathematical rules and constants that are finely tuned to an astonishing degree to allow for the existence of life. The cosmological constant, the strength of gravity, the mass of an electron, if any of these were slightly different, stars wouldn't form, atoms would fly apart, and life as we know it would be impossible. This fine-tuning could be seen as the chosen parameters of the simulation, the initial conditions set by the programmers. This inevitably brings us to the most profound question of all: consciousness. If we are in a simulation, are we truly conscious, or are we sophisticated philosophical zombies, acting as if we are conscious without any inner experience? This is the hard problem of consciousness, but now framed within a digital context. If the simulation is detailed enough to perfectly replicate the physics and chemistry that give rise to biological consciousness, then there is no reason to believe our subjective experience is any less real. Pain would still hurt, joy would still feel exhilarating, and love would still be profound. Our consciousness would be an emergent property of the simulation's processes, just as it is an emergent property of the biological processes in a base reality. We would be conscious beings living inside a constructed world. The analogy of a video game character is useful but limited. A character in a simple game has no inner life. But if a simulation could replicate the staggering complexity of a human brain, down to the quantum level, then that simulated brain would presumably generate genuine consciousness. This leads to a cascade of even deeper questions about the nature of our existence. If this is a simulation, what is its purpose? Are we part of a grand historical experiment, a form of cosmic archaeology where an advanced civilization is running countless simulations to understand its own origins? Are we merely entertainment, a reality show for beings whose lives we cannot comprehend? Or perhaps we are in a training program, a test for developing souls before they graduate to a higher plane of existence? And who or what is the simulator? Are they scientists, gamers, gods, or something beyond our ability to conceptualize? The simulation hypothesis does something remarkable. It merges cutting-edge technology with age-old metaphysics, forcing us to question the very nature of existence, reality, and our place within it. It suggests that the search for the meaning of life might not be about discovering a law of physics, but about uncovering the intent of the programmer. Now, if our reality is indeed a construct, whether holographic or simulated, it forces us to confront a property of the universe that seems to defy the very idea of separation itself: quantum entanglement. This is the baffling phenomenon where two particles become inextricably linked, forming a single, unified quantum system regardless of the physical distance between them. Change the property of one like its spin or polarization, and its partner instantaneously responds, mirroring that change as if no space existed between them at all. This connection isn't just fast, it's immediate, operating outside the constraints of the universe's speed limit, the speed of light. This isn't a theoretical curiosity. It's a rigorously tested and confirmed fact of nature, one that so disturbed Albert Einstein that he famously derided it as spooky action at a distance. He believed this instantaneous influence violated the fundamental principles of locality and realism, the ideas that objects are only influenced by their immediate surroundings and that they have definite properties even when we're not looking. Einstein was convinced quantum mechanics must be an incomplete theory, that there must be some hidden variables at play that we simply hadn't discovered yet. Decades of ingenious experiments, however, have proven Einstein wrong on this point. Physicist John Bell devised a mathematical theorem that could test for these hypothetical hidden variables. When scientists like Elaine Aspect conducted these Bell test experiments, the results were clear and unambiguous. No local hidden variables could explain the correlation between the particles. The spooky action was real. The particles were communicating, or rather correlating their states, in a way that completely bypassed the space between them. This forces a profound revision of our understanding of space itself. We tend to think of space as an empty container, a void that separates objects. But entanglement suggests that at its most fundamental level, this separation is an illusion. The universe may be far more deeply interconnected than it appears, with space not being a barrier but a kind of emergent property that arises from a deeper, non-spatial reality. The particles aren't sending a signal through space. They are behaving as if they are a single entity, reminding us that the space we perceive is not the whole story. This radical interconnectedness naturally leads to a tantalizing question. If subatomic particles can be instantly linked across the cosmos, could consciousness exhibit a similar property? Some theorists and researchers propose that our minds might not be the isolated, individual islands we perceive them to be. Perhaps, through a mechanism we don't yet understand, consciousness itself is non-local, capable of connections that transcend the physical brain. This could provide a potential framework for understanding elusive phenomena like telepathy or collective intuition, where information seems to be shared without any conventional sensory input. It's a speculative leap, but it's one that connects the bizarre world of quantum physics to the mysteries of human experience, suggesting that the unity we see at the quantum level might be reflected in the realm of mind. We don't have to look to the edges of physics or parapsychology to find evidence of entanglement's power. It might be operating right in our backyards, inside the leaves of plants. The process of photosynthesis, which converts sunlight into chemical energy, is remarkably efficient. For years, scientists couldn't quite figure out how a photon of light, absorbed by a molecule in a plant cell, could almost instantly find the most efficient path to the reaction center where its energy is used. The answer, it appears, involves quantum entanglement. The energy doesn't hop randomly from one molecule to the next. It exists in a superposition, essentially exploring all possible pathways simultaneously through a wave-like entangled state, and then choosing the most optimal one. This isn't some delicate effect that only occurs in a vacuum at near absolute zero. It's happening inside warm, wet, noisy biological systems. This discovery in quantum biology shows that nature has been harnessing these non-local effects for billions of years, using them to drive one of the most fundamental processes for life on Earth. It's a powerful demonstration that entanglement isn't just a weird quirk of physics for laboratory experiments. It's a functional tool woven into the fabric of our living world. All of this culminates in a truly mind-expanding possibility. If particles can maintain a connection that ignores space, and if this principle is so fundamental that biology uses it, then what does that say about the nature of our own awareness? Could our consciousness, in some way, also transcend the spatial boundaries of our skulls? This doesn't necessarily mean we can read each other's thoughts on command, but it opens the door to the idea that the separateness we feel from each other and the world might be a perceptual filter, a feature of our evolved brains that helps us navigate daily life, but not the ultimate truth. Underneath the illusion of individuality, there might be a deeper layer of unity, a cosmic connectedness where the concept of here and there loses its meaning, and where the universe reveals itself not as a collection of isolated parts, but as a single, indivisible whole. But as we contemplate the universe's strange interconnectedness, we must also confront its most dominant yet most elusive residents: dark matter and dark energy. Together, these two mysterious entities constitute a staggering 95% of everything in the cosmos, yet we cannot see them, touch them, or directly detect them with any instrument we have yet devised. They are the ultimate cosmic ghosts, invisible forces that shape the destiny of galaxies and the expansion of the universe itself, and their true nature remains one of the greatest unsolved puzzles in all of science. Yet, their profound influence on the structure of reality inevitably leads us to wonder if they might also play a role in the deepest mystery of all, the nature of consciousness. Let's start with dark matter, the universe's hidden architect. We know it exists not because we can see it, but because of its immense gravitational pull. In the 1930s, astronomer Fritz Zwicky was studying the Coma cluster of galaxies and noticed something bizarre. The individual galaxies were moving so fast that the cluster's gravity, based on the amount of visible matter, stars, gas, and dust, should not have been strong enough to hold them together. The entire cluster should have flown apart. He concluded there must be some unseen dunkel materie, or dark matter, providing the extra gravitational glue. Decades later, the pioneering work of astronomer Vera Rubin provided undeniable proof. By meticulously measuring the rotation speeds of stars in spiral galaxies, she found that stars on the outer edges were orbiting just as fast as those near the center. According to the laws of gravity, these outer stars should be slowing down like planets farther from the Sun. The only explanation was that each galaxy is embedded within a massive, invisible sphere of matter, a halo of dark matter that extends far beyond the visible edge of stars. This dark matter provides the essential scaffolding upon which galaxies are built. Without it, our Milky Way and every other galaxy would have never formed. It is the invisible skeleton of the cosmos, and we are merely the luminous flesh upon its bones. Then there is dark energy, an even more perplexing phenomenon. In the late 1990s, two independent teams of astronomers made a discovery that would win them the Nobel Prize. They were measuring the distances to far-off supernovae, expecting to find that the expansion of the universe was slowing down over time due to the gravitational pull of all matter. To their astonishment, they found the opposite. The expansion is not slowing down, it is accelerating. The universe is flying apart faster and faster. Something is counteracting gravity on the largest scales, and physicists call this something dark energy. It behaves like a kind of anti-gravity, an inherent property of empty space itself that pushes galaxies away from each other. While dark matter pulls things together to build structure, dark energy pushes everything apart, ultimately determining the fate of the cosmos. One provides the cosmic attraction, the other the cosmic repulsion. Now, what could these enigmatic forces possibly have to do with consciousness? This is where we venture into highly speculative but fascinating territory. Some theorists propose that if consciousness is indeed a fundamental feature of the universe, as we discussed earlier, then it must interact with all of its components, including the dark sectors. Could dark matter, which vastly outweighs normal matter, serve as a medium for consciousness? Perhaps its particles, whatever they may be, are not just passive gravitational actors, but could interact in subtle ways with the processes of the mind, forming a hidden network that connects conscious beings across the galaxy. It's a wild idea, but it stems from the simple fact that we are made of the minority stuff of the universe, the ordinary atoms that make up planets and people. The majority is this mysterious dark matter, constantly flowing through us. Billions of dark matter particles are passing through your body every second without a trace. If consciousness has a non-physical component, could it be interacting with this vast, unseen ocean of matter? Similarly, dark energy's role as the driver of cosmic expansion invites a metaphorical, and perhaps even literal, connection to the expansion of awareness itself. In many spiritual and philosophical traditions, enlightenment or higher consciousness is described as an expansion of the mind, a breaking free from the gravitational pull of the ego and limited perception. Is it merely a poetic coincidence that the physical universe is also in a state of accelerating expansion? Or could there be a deeper, unknown principle linking the physical growth of the cosmos with the potential for psychological and spiritual growth? Perhaps dark energy is not just a force out there in space, but a force that also operates within the fabric of consciousness, a tendency toward greater complexity, freedom, and awareness. The analogies are powerful. Dark matter is like the invisible current of a deep ocean, directing the motion of the visible ships on the surface. Dark energy is like the rising tide that lifts all boats, an expansive force that cannot be seen, only witnessed in its effects. These concepts force a profound humility. We have mapped the human genome and landed on the moon, yet we still don't know what makes up 95% of our own universe. This immense gap in our knowledge is a thrilling frontier. Could cracking the code of dark matter and dark energy do more than just complete our standard model of physics? Could it finally provide a bridge between the objective world of matter and the subjective world of mind, revealing that the two are not separate at all, but different expressions of a single, unified reality that is far stranger and more wonderful than we have ever dared to dream? Yet if the universe is mostly composed of these mysterious, unseen entities, what about the very fabric of spacetime that they inhabit? This leads us to a theory so ambitious it seeks to be the ultimate theory of everything, a framework that promises to unify all forces of nature and all particles into a single, elegant description of reality. This is string theory, and its most astonishing implication is that our familiar universe of three spatial dimensions is merely the surface of something far deeper and more complex. According to this idea, the fundamental building blocks of nature are not point-like particles but unimaginably tiny, vibrating loops of energy strings. And for the mathematics of these strings to work, to vibrate in the specific ways that produce all the known particles and forces, they require a reality with more than just the three dimensions of space and one of time we experience. They demand a cosmos with 10 or even 11 dimensions. The primary goal of string theory is one of the most sought-after achievements in all of physics, to seamlessly unite the two great but incompatible pillars of modern science. On one hand, we have quantum mechanics, which describes the bizarre and probabilistic world of the very small, atoms and subatomic particles. On the other, we have Einstein's general relativity, which beautifully explains the force of gravity and the nature of space, time, and the very large planets, stars, and galaxies. The problem is that these two theories speak completely different mathematical languages and break down when forced to describe each other's domains, such as the singularity at the heart of a black hole. String theory aims to be the universal translator. In this framework, a particle like an electron isn't a dimensionless dot. It's a tiny string vibrating at a specific frequency. Change the vibration and the string becomes a photon, a quark, or any other particle. Crucially, one of the vibrational patterns of the string perfectly describes the graviton, the hypothetical particle that carries the force of gravity. This is the theory's breathtaking promise. Gravity is naturally woven into the quantum tapestry, not forced in from the outside. But where are these extra dimensions? If we need 10 or 11 dimensions for the math to work, why do we only perceive 3 of space? The most prevalent answer is a process known as compactification. Imagine a long, thin garden hose stretched across a field. From a distance, it looks like a one-dimensional line, but if you were an ant crawling on that hose, you would discover a second dimension, the circular dimension going around the hose's circumference. The extra dimensions of string theory are thought to be curled up or compactified into incredibly tiny, complex shapes at every single point in space, far too small for us to perceive directly. These shapes are called Calabi-Yau manifolds, intricate six-dimensional geometries that determine the properties of our universe. The specific way these dimensions are curled up dictates the vibrational patterns of the strings, which in turn sets the laws of physics we observe, the strength of gravity, the mass of the electron, the number of particle families. Our entire universe, with all its diversity, might be the unique consequence of how these six hidden dimensions are folded. This compactification might even explain one of the most enduring puzzles in physics: why gravity is so astonishingly weak compared to the other fundamental forces. A small fridge magnet can generate enough electromagnetic force to overcome the gravitational pull of the entire Earth. Why is gravity such a feeble pushover? Some string theory models suggest that while the electromagnetic force is confined to our familiar three-dimensional brain of reality, short for membrane gravity, might be the only force that can leak out into the extra dimensions. Its strength would be diluted, spread thin across all the dimensions, which is why it appears so weak from our limited, three-dimensional perspective. It's like comparing a sound wave in the open air, which spreads out in all directions and fades quickly, to a sound wave trapped in a narrow pipe, which remains concentrated and powerful. Gravity is the sound wave in the open air of a higher dimensional space. This naturally invites a profound and speculative connection to consciousness. If these higher dimensions are real, albeit hidden, could they be more than just abstract mathematical constructs? Could they be realms that are not physical in the way we understand, but perhaps mental or spiritual? Some thinkers and mystics have proposed that altered states of awareness, achieved through deep meditation, psychedelic experiences, or near-death events, might involve a temporary uncurling of perception, allowing the mind to glimpse or access these additional dimensions. In such a state, the barriers of ordinary consciousness might fall away, revealing a reality of greater depth and connectivity. The physicist Brian Greene, who has done so much to popularize these ideas, often uses powerful visual metaphors to make them accessible. He describes our universe as like the length and width of a piece of paper, while the extra dimensions are like the paper's thickness, always there, but so tiny we normally ignore it. If we could somehow shift our perspective to that of a being that perceives these extra dimensions, our entire understanding of reality would be transformed. We would see the unity underlying all things, the hidden connections that bind the cosmos together into a single, multidimensional whole. This raises an incredible possibility that the journey inward into the depths of our own consciousness and the journey outward into the fundamental architecture of the universe might ultimately be the same journey, leading to a revelation that mind and cosmos are inseparable partners in a dance of dimensions far beyond our ordinary comprehension. Considering the mind-boggling precision required for our existence, it seems the universe is playing a game with impossibly high stakes, and somehow we won. This isn't a metaphorical observation, it's a mathematical one. The fundamental constants and forces that govern our cosmos are balanced on a razor's edge with an accuracy that is almost incomprehensible. The strength of gravity, the mass of a proton, the precise value of the cosmological constant driving the universe's expansion. If any of these were altered by even a fraction of a percent, the universe as we know it would not exist. There would be no stars, no planets, and certainly no one around to wonder about it all. This breathtakingly precise fine-tuning is one of the most profound puzzles in all of science, and it forces us to confront a deeply philosophical question: why is the universe so perfectly suited for life? To grapple with this, scientists and philosophers developed the Anthropic Principle. This isn't a single idea, but rather a framework for thinking about our observations. The most straightforward version is known as the weak Anthropic Principle. It simply states that we must find ourselves in a universe capable of supporting our existence. In other words, we observe the constants to be finely tuned because if they weren't, we wouldn't be here to observe anything at all. It's a selection effect. Imagine a puddle waking up one morning and thinking, "This hole I'm in fits me perfectly. It must have been made just for me." The hole wasn't designed for the puddle. The puddle simply conforms to the shape of the hole. The weak principle suggests our universe is that hole, and we are the puddle that happens to fit. A much stronger and more controversial claim is the strong Anthropic Principle. This version proposes that the universe must, in some way, be compelled to eventually have conscious and sapient life arise within it. This isn't just a statement about our lucky position. It hints at a deeper law or necessity that the universe should produce observers. Proponents of this view, like the mathematicians John Barrow and Frank Tipler, who extensively explored these concepts, argue that consciousness might not be a random accident but an integral part of the cosmic process. In this perspective, the universe becomes self-aware through us, and the constants are set to ensure this outcome. It moves from an observation of coincidence to a suggestion of purpose, blurring the line between physics and metaphysics. This is where our earlier discussion of the multiverse provides a powerful, if staggering, counterpoint. The fine-tuning problem, which seems so miraculous in a single universe model, becomes almost inevitable in a multiverse. If there are an infinite or near-infinite number of universes, each with its own randomly set physical constants and laws, then it is statistically guaranteed that at least one universe will have the perfect combination for life. We just happen to live in that one lucky universe. The incredible unlikelihood is swallowed by the sheer immensity of possibility. In this view, there is no fine-tuner, there is just a cosmic lottery, and we are the holders of the winning ticket. The multiverse acts as a kind of cosmological Darwinism. Only the universes fit for life will ever have observers to remark upon their fitness. Take the cosmological constant, the energy density of empty space responsible for the accelerating expansion of the universe. Its measured value is astonishingly small. If it were even slightly larger, the universe would have expanded so rapidly after the Big Bang that galaxies and stars could never have formed. If it were slightly more negative, the universe would have collapsed back in on itself almost immediately. The acceptable range for this value to allow for a life-permitting universe is vanishingly narrow. In a multiverse, most universes have a cosmological constant that is either too large or too small, and are therefore barren and empty. We simply inhabit the rare exception. This fine-tuning debate inevitably draws consciousness back to the center of the stage. If the strong Anthropic Principle holds any weight, it implies that the universe is not just compatible with consciousness, but is inherently biased toward its emergence. This suggests a cosmos that is, in some profound way, mindful or designed with mind in mind. It resonates with ideas from quantum mechanics, where the act of observation appears to shape reality, and with philosophical idealism, which posits that reality is fundamentally mental. Are we merely passive inhabitants of a lucky universe, or are we active participants in a cosmos that requires observers to bring it into full being? The fine-tuning of the universe forces us to confront the possibility that our existence is not a fleeting accident in an indifferent void, but may be connected to the deepest logic of reality itself, a reality that seems to have been expecting us all along. But if the universe is so precisely tuned for our existence, how can we even measure such fine-tuning when our very measurements of time and space are not fixed, but fluid and relative? This brings us to one of the most experimentally verified and yet deeply counterintuitive consequences of Einstein's revolutionary theories, time dilation. The very rate at which time flows is not a universal constant ticking away the same for everyone everywhere. Instead, it is elastic, stretching and compressing based on two key factors, gravity and velocity. This isn't a philosophical abstraction. It's a physical reality that has been measured with astonishing precision, forcing us to abandon the comforting notion of a single, objective clock for the universe. The first pillar of this idea is special relativity, which Einstein introduced in 1905. It tells us that the faster you move through space, the slower you move through time. This is velocity time dilation. Imagine two identical clocks. One stays on Earth, while the other is placed on a spacecraft traveling at an immense fraction of the speed of light. To an observer on Earth watching the spacecraft through a powerful telescope, the clock on the ship would appear to be ticking noticeably slower, the astronaut aging more gradually. From the astronaut's perspective, however, everything would feel normal. Their clock would seem to tick at its usual rate. The stunning conclusion is that both perspectives are equally valid. There is no privileged frame of reference, there is only relative motion. This leads directly to the famous twin paradox. One twin becomes an astronaut and embarks on a high-speed journey to a distant star and back, while the other remains on Earth. Upon the astronaut's return, due to the effects of time dilation, they would be significantly younger than their Earth-bound sibling. The paradox is only apparent. It's resolved by the fact that the traveling twin must accelerate and decelerate to turn around, breaking the symmetry of their inertial frames. A decade later, Einstein's general relativity added another, even more profound layer. Gravity itself is a warping of space-time, and this warp affects the flow of time. This is gravitational time dilation. The stronger the gravitational field, the more space-time is curved and the slower time passes. A clock placed closer to a massive object, like at the base of a mountain or on the surface of the Earth, will tick slower than a clock further away, like at the mountain's peak or on a satellite in orbit. Your head is literally aging faster than your feet, though the difference is infinitesimally small. This effect is crucial for the accuracy of the global positioning system. The GPS satellites orbiting Earth are both moving at high speed relative to the ground and are in a weaker gravitational field. Their onboard atomic clocks are therefore affected by both types of time dilation. If the engineers at NASA did not constantly correct for these relativistic effects, the entire system would become useless, generating location errors of several miles within just a single day. The fact that your phone can guide you to a coffee shop is daily, mundane proof that Einstein was right. We have direct experimental confirmation beyond GPS. In 1971, physicists Joseph Haefel and Richard Keating flew incredibly precise atomic clocks around the world on commercial airliners. When they compared these traveling clocks to identical ones that had remained at the U.S. Naval Observatory, they found a discrepancy. The clocks that had flown at high altitude and speed were indeed behind by a few hundred nanoseconds, exactly as predicted by relativity. Time itself had passed more slowly for them. This undeniable physical reality invites a fascinating psychological question. If clocks can experience time dilation, what about consciousness? If an astronaut on a near-light-speed journey experiences only 10 years of ship time while a century passes on Earth, how would they feel that decade? Would their internal sense of time, their stream of consciousness, remain subjectively normal, even as their biological aging slowed to a crawl relative to everyone back home? Anecdotes from astronauts on the International Space Station, who experience a much smaller but still measurable time dilation effect, don't report any strange internal feelings of time slowing down. Their perception seems to match their local clock. This suggests that consciousness is anchored to its local frame of reference. Your subjective experience of time's flow is tied to your immediate physical environment and your velocity relative to it. There is no universal now that your brain can tap into. You are always experiencing the now of your own specific location in the curved tapestry of spacetime. Einstein himself grappled with the implications of this, famously writing in a letter to the family of a deceased friend, "Now he has departed from this strange world a little ahead of me." That means nothing. People like us who believe in physics know that the distinction between past, present, and future is only a stubbornly persistent illusion. For Einstein, the block universe implied by his equations, where all of time exists simultaneously, was the deeper reality. Our conscious experience of a flowing present moment is just that, an experience, a psychological phenomenon generated by our brains as they process information in a particular sequence within the block. Time dilation shows us that this illusion is not even consistent. It runs at different rates for different observers. So if there is no true, universal now, what is consciousness truly anchoring itself to? It seems to be anchoring itself to its own local slice of the eternal block, creating a personal, subjective reality that is real to the experiencer but relative to everything else. This doesn't diminish our experience. It reveals that our conscious awareness is not a passive witness to an absolute timeline, but an active participant in a relativistic universe, intimately woven into the very fabric of a spacetime that is far more dynamic and interconnected than we could ever perceive with our senses alone. If the flow of time is not a fundamental river but a relative trick of perception, as Einstein's work suggests, then what is the true nature of time itself? This question leads us directly to one of the most profound and mind-bending implications of relativity, the block universe theory, a view also known as eternalism. In this model, the entire cosmos, every event from the Big Bang to the farthest future, is not unfolding moment by moment. Instead, it is a single, static, four-dimensional block where the past, present, and future all exist simultaneously and eternally. Time, in this view, is simply another dimension, much like the three dimensions of space. Your birth, your life, and everything that will ever happen are not becoming and then fading away. They are permanently fixed in their location within this vast cosmic structure, just as the city of Paris is fixed at a specific latitude and longitude. We perceive a flow only because our consciousness is moving along our personal world line, illuminating one slice of the block at a time. This radical idea is not philosophical speculation. It is the most straightforward interpretation of Einstein's equations of relativity. In his theory, there is no universal now that all observers can agree on. Your present moment and the present moment of an astronaut near a black hole are not the same. Since there is no privileged frame of reference, the only consistent way to view reality is to treat all moments across all frames as equally real. The distinction between past, present, and future becomes a matter of perspective, not an objective feature of the universe. This directly challenges our most visceral experience, the feeling of temporal becoming, the sense that the future is open and unknown while the past is fixed and gone. In the block universe, change is an illusion. Nothing is happening, everything just is. The universe is a frozen tapestry, a completed book where every chapter exists at once, and we are simply reading it page by page. This denial of temporal becoming has deep philosophical roots, famously debated by the early 20th century philosopher J.M.E. McTaggart. He argued that time is unreal because our descriptions of it are inherently contradictory. We can order events in two ways. In the B series, which is the objective, unchanging order of events, like the year 1969 is before the year 2024, and the series, which is the subjective, flowing now like this present moment is now. McTaggart contended that the series, the feeling of a moving present, is essential for our concept of time, but it is also logically impossible because every event is simultaneously past, present, and future from different perspectives. He concluded that since the series is flawed, time itself must be an illusion. The block universe view, emerging from physics decades later, provides a powerful framework for his argument, suggesting that the only reality is the timeless B-series, the permanent, unchanging order of events in the four-dimensional block. So how does our consciousness, with its undeniable feeling of a flowing present, fit into this static reality? How do we navigate a block where everything is already written? One compelling analogy is the spotlight theory of consciousness. Imagine the entire four-dimensional block universe is a vast, dark landscape. Your conscious awareness is a bright spotlight that moves steadily along the timeline, illuminating one moment at a time. The landscape itself, all of past and future, is always there, real and existing, but you only experience the part currently lit up by the beam of your consciousness. Another powerful metaphor is a DVD. The entire movie, from opening credits to final scene, is encoded on the disc all at once. It is all present, but when you play it, the laser in the DVD player reads the information sequentially, creating the experience of a story unfolding in time. In this analogy, the DVD is the block universe, and the laser is your conscious awareness, moving through the data to generate the illusion of change and flow. This immediately raises one of the most unsettling questions we can ask ourselves. If the entire future is already out there, fixed in the block just like the past, then what becomes of free will? Are our choices and decisions merely an illusion, a predetermined script we are helplessly acting out? This is the ancient philosophical problem of determinism, now dressed in the language of modern physics. If the future already exists, then every decision you will ever make is already set in the cosmic stone. The feeling of weighing options and making a choice is just the spotlight of your consciousness passing over that predetermined event. Some find this idea horrifying, a removal of agency and meaning. Others find a strange comfort in it, a sense that every tragedy and joy is eternally preserved as part of a grand, unchanging whole. It challenges us to reconsider what free will might even mean. Perhaps it is not about changing a predetermined future, but about the subjective experience of being the complex process that generates the outcome. You are not a puppet reading lines, you are the entire, intricate mechanism of decision-making that is itself a permanent part of the block. This stark, static view of reality stands in the most dramatic contrast to our lived, everyday experience. We feel the urgency of the present, we regret the past, and we anticipate the future with hope and anxiety. The block universe theory does not ask us to deny this powerful feeling, but to understand it as a remarkable feature of conscious beings within a relativistic cosmos. Our perception of time's flow may be the mechanism by which a four-dimensional organism, embedded in a four-dimensional world, makes sense of its own existence. It is the lens through which we experience the eternal, allowing us to engage with a reality that is, in its ultimate nature, far stranger and more magnificent than our fleeting moments of now could ever suggest. Yet if the entire cosmic block is frozen and predetermined, how does anything ever actually happen? This question slams us directly into the bizarre, probabilistic heart of quantum mechanics, where the very act of observation seems to play a starring role in shaping reality itself. The most famous and historically dominant way of understanding this is the Copenhagen interpretation, pioneered by figures like Niels Bohr and Werner Heisenberg in the 1920s. At its core is the concept of the wave function, a mathematical expression that describes all the possible states a quantum system can be in, like an electron being in a superposition of spinning both clockwise and counterclockwise at the same time. This isn't just a lack of knowledge, it's a genuine blurriness of existence. But here's the strange part: the moment you measure or observe that system, this shimmering cloud of possibilities instantly collapses into a single, definite outcome. The electron chooses a spin. The famous Schrödinger's cat is both dead and alive in its box until someone opens the lid and looks, forcing a single, grim reality to snap into place. Bohr himself captured the oddity of this when he reportedly said, "Anyone who is not shocked by quantum theory has not understood it." The Copenhagen interpretation places the observer, or at least the act of measurement, at the very center of this process, suggesting that reality remains in a fuzzy, unrealized state of potential until it is observed, effectively making consciousness the catalyst that crystallizes the world. This line of thinking was pushed to its most radical extreme by two of the 20th century's greatest mathematical physicists, John von Neumann and Eugene Wigner. In their formulation, known as the von Neumann-Wigner interpretation, it's not just any measurement device that causes the collapse of the wave function. After all, a Geiger counter or a photographic plate is just a physical object itself, made of atoms that should also be governed by quantum rules and exist in superpositions. They argued that there must be a final, irreducible line where the quantum weirdness stops, and that line is the conscious mind of the observer. Only a non-physical, conscious entity can finally collapse the wave function and bring about a concrete reality. Wigner went so far as to propose a thought experiment, often called Wigner's friend. Imagine a physicist in an isolated lab performing a quantum experiment, say, measuring the spin of an electron. To Wigner, outside the lab, the entire system, his friend, the lab, and the electron, is in a superposition until he opens the door and asks for the result. It is his own act of conscious observation that finally resolves the entire entangled mess into a single history. Wigner famously stated, "It was not possible to formulate the laws of quantum mechanics in a fully consistent way without reference to the consciousness." This view essentially proposes that the universe requires a witness to bring it into being, placing mind not just in the brain, but as a fundamental force in physics. However, this profoundly mind-centric view has faced significant criticism and competing explanations. The primary objection is that it seems to introduce a mysterious, almost magical element into what should be a physical theory. How does an intangible consciousness interact with the physical world to cause collapse? This has been derided by some as a new form of dualism, a ghost in the machine for the quantum age. Furthermore, it leads to bizarre paradoxes about the nature of consciousness itself. Does a cat have enough consciousness to collapse its own wave function? What about a worm or a single-celled organism? The theory offers no clear threshold, making it scientifically problematic. Much of this controversy has been addressed by a more modern understanding known as quantum decoherence. This theory explains the appearance of wave function collapse without needing any conscious observer at all. The key insight is that quantum systems are never truly isolated. The moment a quantum particle interacts with its environment, a single photon of light, a molecule of air, it becomes inextricably entangled with it. This entanglement rapidly spreads the quantum information out into the environment in a way that is effectively irreversible for the original system. From the perspective of any local observer, the superposition is destroyed, and the system appears to have collapsed into a single state. It's not that consciousness causes the collapse, It's that the relentless interaction with the environment forces quantum systems to behave in a classical way. The role of the observer is then simply to become entangled with the system and record the outcome, not to magically cause it. In this view, the moon is most certainly there when no one is looking, because it is constantly interacting with sunlight, cosmic rays, and the gravitational field, keeping it firmly in a classical state through endless decoherence. The fascinating quantum eraser experiment provides a stunning demonstration of how observation and information are deeply linked. In a typical setup, particles like photons are sent through a double-slit apparatus, creating an interference pattern that indicates wave-like behavior. If you try to determine which slit each photon goes through, the interference pattern vanishes as the photons are forced to act like particles. But the quantum eraser adds a twist. It uses entangled photons and a clever setup that allows you to erase the which path information after the photons have already hit the detector. Astonishingly, if this information is erased, the interference pattern magically reappears, even though the measurement on the entangled partner happened later. This suggests that the outcome isn't fixed until the entire experimental context, including the eventual erasure of information, is settled. It's not about a conscious observer looking at the data in real time. It's about the availability of information that could, in principle, determine the path. The experiment highlights that quantum reality is contextual and relational, deeply tied to what can be known, rather than what is consciously seen. This leaves us with a profound and unresolved question that straddles the line between physics and philosophy. Does the universe fundamentally require a conscious observer to bring it into definite existence, as Wigner believed? Or is consciousness merely an incidental spectator, a fascinating but passive byproduct of a physical process that would proceed identically in an empty universe, as Decoherence suggests? The debate forces us to confront the very nature of reality and our place within it. Are we the authors of the cosmic story, or are we merely readers discovering a narrative that was already written? This mysterious role of the mind in physics remains one of the most tantalizing and controversial frontiers of human knowledge, a deep puzzle that continues to challenge our understanding of what it means to be and to observe. But what if the interconnectedness we sense isn't just a quantum fluke or a spiritual ideal, but a literal biological fact woven into the fabric of nature itself? This leads us to one of the most controversial and fascinating theories to emerge in the last half-century, a concept that boldly challenges the purely mechanistic view of life, Rupert Sheldrake's theory of morphic fields. A biochemist by training, Sheldrake looked at the standard model of biology and saw a critical piece missing. The prevailing view is that everything about an organism is determined by its genes and its environment, a kind of complex machine. But Sheldrake asked a simple, profound question. Where is the memory? How does a seed grow into an oak tree and not a pine tree? Genetics provides the blueprint for making proteins, but it doesn't contain the instructions for the intricate three-dimensional form, the shape and pattern of the whole organism. To explain this, he proposed the existence of morphic fields, invisible, non-physical patterns or matrices that shape the development and behavior of all natural systems, from crystals to plants to human societies. These fields are not fixed, they are habits. The more a particular pattern is repeated, like the shape of an oak leaf or the song of a specific bird species, the stronger and more ingrained its morphic field becomes, making it easier for subsequent systems to fall into that same pattern. This process, which Sheldrake calls morphic resonance, suggests that nature is not just governed by fixed laws but by habits that evolve over time. The implications of this idea ripple across countless fields of study, offering elegant explanations for phenomena that conventional science struggles with. Take animal behavior. In a famous example, laboratory rats in one part of the world often learn to run a new maze more quickly than earlier generations did. The standard explanation is improved breeding or better lab techniques, but Sheldrake's theory proposes a different cause. As more rats learn the maze, its solution becomes easier for rats everywhere to learn through morphic resonance, as if the knowledge is accumulating in a collective field. This same principle could apply to human learning. Have you ever noticed that a difficult skill, like solving a Rubik's Cube or mastering a complex video game, seems to become easier for the general population over time? The first pioneers struggle for weeks, but soon tutorials spread and records are broken with astonishing speed. While we credit better instruction, Sheldrake would suggest that the morphic field for that skill has been strengthened by all those who practiced before, making it subtly easier for newcomers to tap into that accumulated know-how. Even the inanimate world might be influenced by these fields. When a chemist first synthesizes a new crystal compound, it can be notoriously difficult to get it to form correctly. But after it has been crystallized in a few labs around the world, it suddenly becomes much easier for everyone else. The standard explanation is that tiny seed crystals are accidentally carried on clothing or in equipment, contaminating other experiments. Sheldrake's alternative is that the morphic field for that specific crystal structure has been established, making it easier for the molecules to fall into that habitual pattern anywhere on Earth. This challenges the very bedrock of mechanistic science, proposing that memory is not stored solely inside brains, but is instead inherent in these fields, with brains acting more like tuning radios, receiving and transmitting information from the collective memory of their species. This is where the theory makes its most daring leap, directly connecting to the nature of consciousness itself. Sheldrake suggests that our thoughts themselves may have their own morphic fields. A particular idea or memory might not be locked inside your skull, but could be a pattern you are tuned into. This could provide a potential mechanism for seemingly psychic phenomena like telepathy. If two people are closely bonded like a mother and child or twins, they might be tuned to similar emotional and mental frequencies, allowing one to intuitively sense when the other is in distress, even across great distances, because the thought or feeling resonates within their shared morphic field. This offers a scientific, if unorthodox, framework for Carl Jung's concept of the collective unconscious, a shared reservoir of archetypes and memories that all humanity can access. It could even explain the experience of synchronicity, those meaningful coincidences where an internal thought seems to manifest in the external world, as if your mind and the universe were momentarily resonating in harmony. Unsurprisingly, such a radical departure from established science has faced fierce criticism. The main charge against morphic fields is that they are untestable and therefore not scientific. Critics argue that the theory is a classic God of the gaps argument, inventing a mysterious force to explain anything we don't yet understand. They contend that the examples Sheldrake uses, like the rats learning mazes faster, have more plausible explanations rooted in genetics, selective breeding, or unconscious cues from experimenters. The scientific establishment largely dismisses morphic fields as pseudoscience, arguing that there is no known physical mechanism for how such fields could work or how information could be transmitted across them without energy or signals that violate known physical laws. To his credit, Sheldrake has directly engaged with these criticisms. He argues that the theory is indeed testable and has proposed numerous experiments. For instance, he suggests that if you taught animals a new trick in one location, animals of the same species in a completely isolated location should learn the trick more quickly once the first group has mastered it, even with no possible physical communication between them. While some of his own experiments have claimed positive results, they have been criticized for methodological flaws and have not been widely replicated by the mainstream scientific community. Sheldrake counters that the resistance is more dogmatic than scientific, a refusal to consider any explanation that falls outside the narrow confines of mechanistic materialism. He points out that all new paradigms face intense skepticism, and that the history of science is filled with ideas once considered ridiculous that are now accepted fact. Whether morphic fields will ever undergo that transition remains to be seen, but the theory continues to captivate those who feel that our current models of reality are incomplete, offering a compelling vision of a living, learning universe where memory is not trapped in the past but is a dynamic field shaping the present and future. But if the universe is a tapestry of habits and memories woven through morphic fields, what is the loom upon which this tapestry is woven? To find an answer, we must journey down to the very ground of being, to a realm of pure potential that underlies all of space and time, the quantum vacuum. Forget everything you think you know about empty space. It is not a true void, a barren nothingness. According to quantum field theory, what we call a vacuum is actually a seething, bubbling sea of energy, alive with unimaginable activity. At the very smallest scales, far below the detection of our finest instruments, subatomic particles and their anti-particle counterparts are constantly flashing into and out of existence. They are called virtual particles, and they borrow energy from the vacuum for an infinitesimally brief moment, only to annihilate each other and return it, all in accordance with the uncertainty principle. This ceaseless, frantic dance means that every single cubic centimeter of so-called empty space is actually teeming with a colossal amount of energy, known as zero-point energy because it exists even at absolute zero, the temperature at which all classical motion ceases. This isn't speculative, it's a fundamental prediction of our most successful physical theories, and it suggests that the vacuum is not empty but is instead the fundamental substrate of all that is, an infinite reservoir of potential from which everything emerges. We even have a remarkable, tangible demonstration of this bizarre reality, the Casimir effect. Imagine two uncharged, perfectly smooth metal plates placed incredibly close together in a vacuum, only a few nanometers apart. Classical physics would suggest nothing should happen between them, but in the quantum world something extraordinary occurs. The space between the plates is so narrow that it can only accommodate virtual particles with certain wavelengths. However, the space outside the plates has no such restriction. It can support virtual particles of all wavelengths. This creates a pressure imbalance. The greater number of virtual particles and their energy outside the plates literally pushes them together. This tiny but measurable force has been experimentally confirmed, providing direct evidence that the quantum vacuum is real and exerts a physical effect. It's as if you were to take two boats on a perfectly calm sea. The calm is an illusion, for beneath the surface the water is churning with invisible currents that could nudge the boats together. The Casimir effect is our proof of those hidden quantum currents. This leads to a breathtaking and highly speculative possibility. If the vacuum is this unimaginably dense ocean of energy, could it be the source of not just matter, but of mind itself? This is a frontier explored by physicists and consciousness researchers like Hal Puthoff. He and others have proposed that the brain might not generate consciousness like a generator produces electricity, but rather harness it. In this model, the brain could be a sophisticated receiver or transducer, tuning into and interacting with the zero-point field, converting its boundless energy into the ordered flow of our thoughts and awareness. This would elegantly solve the so-called hard problem of consciousness, the question of how subjective experience arises from inert matter. Instead of emerging from neurons, consciousness would be a fundamental property of the universe, and the brain's complex structure would simply allow an individual organism to tap into this cosmic field, to decode a personal stream of awareness from the universal background. Our skulls would not be containers for consciousness, but rather filters or lenses that focus a field which is everywhere at once. This idea finds a curious echo in ancient spiritual traditions and modern meditative practices. Mystics and advanced meditators across cultures often describe reaching a state of pure awareness or consciousness without an object, a feeling of merging with an infinite, silent, and potent ground of all being. They report a dissolution of the ego and a profound sense of interconnectedness with everything. Could these subjective experiences be glimpses of tapping directly into the zero-point field, bypassing the usual filters of the brain? In deep meditation, when brainwave patterns shift and sensory input is minimized, perhaps the mind becomes a clearer receiver for this fundamental energy, allowing for an experience of the unified field that underlies the illusion of separation. The zero-point field, in this view, becomes the scientific correlate of what mystics have called the Akasha, the Tao, or the divine ground of existence, an infinite, intelligent potentiality that is the source of both the physical world and conscious mind. The implications of this are staggering. It suggests that the fabric of space-time and the fabric of thought might be two sides of the same coin, both woven from the same underlying field of zero-point energy. This hidden ocean of potential could be the ultimate source of everything, the great blank canvas upon which the universe paints itself into existence. It hints at untapped possibilities that sound like the stuff of science fiction. Could we one day learn to directly extract energy from the vacuum itself, solving humanity's energy crisis forever? Could we learn to consciously manipulate this field, influencing reality in ways we can scarcely imagine? The zero-point field remains one of the greatest mysteries and potentially the greatest source of discovery, a profound reminder that what we perceive as reality is merely the visible tip of an iceberg, resting on a hidden, luminous depth of infinite potential. What if we have been looking at the universe through the wrong end of the telescope this entire time? The conventional scientific story tells us that life and consciousness are latecomers to the cosmos, accidental sparks of awareness that flickered into existence billions of years after a lifeless universe began. But what if that story is backward? This is the radical, mind-flipping proposition at the heart of biocentrism, a theory championed by renowned scientist and theorist Robert Lanza. Biocentrism, literally meaning life-centered, turns the traditional materialist worldview on its head. It posits that life and consciousness are not accidental byproducts of the universe. They are the very reason for its existence and the fundamental forces that shape its structure. In this view, the cosmos does not give rise to consciousness. Consciousness gives rise to the cosmos. The implications of this idea are so profound they unravel our most basic assumptions about reality, suggesting that the world we perceive is not an external, objective stage, but a deeply personal, conscious construction. At the core of biocentrism is a revolutionary rethinking of space and time. We experience them as the immutable container within which everything happens, the fixed stage and the relentless clock. Lanza argues that this is an illusion. He proposes that space and time are not physical realities existing out there, independent of us. Instead, they are tools of the mind, conceptual frameworks that our consciousness uses to organize and make sense of the sensory information it receives. Think of them not as the theater, but as the very language of the play. They are the grammar and syntax that our minds impose on raw experience to create a coherent narrative. You cannot put life or consciousness in a box of space and time because that box is itself a construct of consciousness. This aligns powerfully with insights from both modern physics and ancient philosophy. Immanuel Kant argued centuries ago that time and space are not empirical concepts derived from experience, but rather the fundamental lenses through which we have any experience at all. Biocentrism takes this philosophical idea and gives it a modern scientific urgency, suggesting that our perception is not just interpreting reality, it is actively participating in its creation. This is where biocentrism finds its most compelling support in the baffling world of quantum mechanics. The famous double-slit experiment, as we've discussed, demonstrates that particles exist in a blurry state of potential until they are observed. The act of measurement of a conscious observer looking seems to force the particle to choose a definite state. For biocentrism, this isn't a strange quantum quirk. It is the fundamental principle of the universe in action. It suggests that reality remains in a state of limbo, a cloud of probabilities, until a conscious interaction collapses it into a specific event. The external world is therefore not a fixed, finished product. It is a work in progress, and consciousness is the artist, constantly bringing it into focus with every observation. This moves the observer from a passive witness on the sidelines to the central player in the drama of existence. The universe needs a viewer to become real. Without a conscious entity to perceive it, does the moon exist in a definite state? Biocentrism would argue that it exists as a shimmering potential, but its solidity and location are contingent upon a conscious interaction. This places an incredible responsibility and power at the feet of life itself. This radical perspective inevitably leads to a profound reevaluation of the one experience every living thing fears most: death. If consciousness is the fundamental reality, then what happens when the individual biological organism that seems to host it ceases to function? Lanza, drawing on his deep expertise in biology and stem cells, proposes that death is not the end of consciousness, but merely a transition. He merges the concept of biocentrism with the many worlds interpretation of quantum mechanics to suggest a form of quantum immortality. The idea is that consciousness is not localized to a single body or a single timeline. In the infinite branching multiverse where every possible outcome occurs, your consciousness is not extinguished at the moment of death in one universe. Instead, it simply aligns with the branch of reality in which you continue to exist. From your first-person perspective, you never experience the end of consciousness. You only experience the timelines in which you survive. This isn't about living forever in a frail, aging body, but about the continuity of conscious awareness always finding a universe where it persists. It's a scientific take on the idea of an eternal soul, not as a religious abstraction, but as a consequence of the fundamental laws of physics and the primacy of consciousness. Anecdotal evidence from countless near-death experiences (ND) adds a powerful human dimension to this theory. Many who have been clinically dead and revived report strikingly similar experiences: a feeling of profound peace, moving through a tunnel toward a loving light, a life review, and an overwhelming sense of being more real and aware than they ever were in their physical body. While skeptics often attribute these to brain chemistry, such as oxygen deprivation or a flood of endorphins, biocentrism offers a different interpretation. What if the dying brain, as its filters and sensory inputs shut down, doesn't generate these experiences but instead allows consciousness to tune into a broader reality beyond the constructs of space and time? The feeling of leaving the body could be a literal experience of consciousness detaching from its biological instrument and operating in its more fundamental, non-local state. These experiences, reported across cultures and throughout history, could be fleeting glimpses of the true nature of a consciousness-based reality, a reality where the death of the body is simply the closing of one chapter, not the end of the book. All of this culminates in a question that is both empowering and daunting. If consciousness is not a passive passenger but the active driver of reality, how can we, as individuals, learn to harness this incredible creative power? This is not about wishful thinking or magical manifestation, but about a deeper understanding of our role in the cosmos. It suggests that our expectations, our beliefs, and our focused attention are not just internal psychological states. They are instruments that interact with the quantum field of possibilities, influencing which potential realities become our actual experience. The well-documented placebo effect is a perfect example of this principle in action. A person's firm belief in the efficacy of a sugar pill can trigger measurable physiological healing processes in their body. Their consciousness, through its expectation, is quite literally altering their physical reality. This implies that by cultivating mindfulness, positive intention, and a deep awareness of our interconnectedness with the universe, we might be able to participate more consciously in the shaping of our lives and our world. Biocentrism does not place us at the mercy of a cold, mechanical universe. It places the universe in all its splendor and mystery within us, inviting us to awaken to our true role as co-creators of everything we see, touch, and know. We have spent so much time searching for the secrets of time in the outer cosmos, in the equations of physics and the orbits of planets. But what if the key has been hidden within us all along? This leads us to a profoundly introspective theory that turns the very notion of time inside out. The idea that time is not a fundamental feature of the external universe, but rather a dimension of consciousness itself, a mental construct that our minds generate to make sense of the ceaseless flow of experience. Imagine for a moment that you are the director of a movie, and the raw footage is a chaotic jumble of every single frame from every single scene, all existing at once in a giant, disorganized pile. Your job as the director is to take that pile and edit it into a coherent, linear story. In this analogy, the pile of frames is the raw data of existence, and the edited film, with its clear beginning, middle, and end, is time as we know it. Your consciousness is the director, the active force that selects sequences and stitches together moments to create the seamless narrative of your life. This is not a new idea. It has deep roots in philosophy. Immanuel Kant, the 18th century German thinker, argued persuasively that time and space are not things we discover in the world, but are instead the fundamental frameworks of our perception. He called them a priori forms of intuition. They are the essential lenses baked into the very hardware of our minds, through which we must necessarily process all incoming sensory data. We cannot experience anything outside of time and space, not because the universe demands it, but because our minds are built that way. For Kant, time was the internal sense, the structure that allows us to organize our inner world of thoughts and feelings, just as space organizes our outer world of objects. Modern cognitive science provides fascinating support for this centuries-old idea, revealing that our brain is not a passive recorder of time, but an active and sometimes clumsy creator of it. The feeling of a smooth, continuous flow is actually a clever illusion woven together by a series of complex neurological processes. Our brain constantly takes sensory snapshots and then, working slightly behind the scenes, edits them into a coherent sequence. This can lead to bizarre temporal glitches. For example, in the flash lag illusion, a flash of light that occurs exactly next to a moving object is perceived as lagging behind it. Our brain, predicting the object's path, literally edits the timeline of events to create a smoother reality. Even more telling are experiments where direct brain stimulation can trigger vivid memories that feel like they are happening in real time, demonstrating that the brain can generate a complete temporal experience from within, completely independent of the external present moment. This shows that the now we experience is not a pinpoint on a timeline but a constructed window of awareness, a best guess our brain makes about what is happening based on slightly delayed sensory information. Perhaps the most compelling evidence for time as a mental construct comes from those who have managed to temporarily switch off the brain's editing software through deep meditation, intense flow states, or sudden trauma. Mystics and seasoned meditators from various traditions consistently report experiences of timelessness, where the constant chatter of the mind subsides and the relentless forward march of seconds and minutes simply dissolves. In these profound states, there is no past to regret and no future to anticipate. There is only a deep, expansive, and eternal present. This is not merely a feeling of losing track of time, like when you're engrossed in a good book. It is a fundamental shift in the very mode of perception, a glimpse of reality operating without the filter of temporal sequencing. Similarly, people who have experienced life-threatening accidents often report that time seemed to dramatically slow down, allowing them to process a vast amount of information in what was objectively a split second. This suggests that in moments of extreme crisis, the brain can switch into a hyper-processing mode, packing more subjective experience into a tiny objective time frame, thereby stretching the fabric of perceived time itself. This reveals time's elasticity not as a property of the cosmos, but as a capability of the conscious mind. Think about the nature of dreams. Within a dream, time can be incredibly fluid and illogical. You can instantly transition from one scene to another, have conversations that last for hours in a dream but only minutes in reality, or even experience events out of order. The dream world operates on its own internal clock, one that is entirely generated by your sleeping consciousness. This dreamlike quality hints at the possibility that our waking perception of time is also a kind of story we are telling ourselves, a narrative framework that is useful for survival and communication, but not necessarily the ultimate truth of reality. If time is indeed a story generated by the mind, this opens up a fascinating and empowering possibility. If we can change the story, can we change our experience of time? Can we, through focused intention and mental training, learn to slow down time during moments of joy or speed it through periods of discomfort? The field of psychology suggests we can to a degree. When we are bored and paying close attention to the clock, time seems to drag. When we are engaged and absorbed in a challenging, rewarding activity, a state psychologists call flow, at times seems to fly by. This is because in flow, the part of the brain that monitors the passing of time largely disengages. We are so fully immersed in the present moment that the internal clock is silenced. By consciously directing our attention and cultivating mindfulness, we may gain a degree of mastery over this internal dimension, not by violating the laws of physics, but by altering our subjective engagement with reality. This perspective does not diminish time, it internalizes it, transforming it from an external tyrant into a personal, malleable experience, a profound reminder that the universe we know is always and forever a universe perceived. What if the very organ we use to perceive reality is itself a masterpiece of illusion, a biological projector crafting the solid world from a sea of interference patterns? This is the captivating premise of the holographic brain theory, a radical model suggesting that our skulls contain not a centralized computer, but a sophisticated holographic processor. The origins of this mind-bending idea lie in a powerful convergence of thought between neurophysiologist Carl Pribram and physicist David Bohm. Pribram was wrestling with a persistent mystery of neuroscience, memory. Despite countless attempts, researchers could not locate a specific memory engram, a discrete physical site where a single memory is stored. No matter which part of a rat's brain they removed, the memory of a learned maze could not be completely erased. It was as if the memory was everywhere and nowhere at once, distributed throughout the entire brain. Pribram found his answer in an unlikely place: the principles of holography. A conventional hologram possesses a miraculous property. If you take a holographic film plate and shatter it into a dozen pieces, you don't get a dozen fragments of the image. Astonishingly, each individual piece, when illuminated with a laser, will still reconstruct the entire original image, albeit with lower resolution. The entire whole is encoded in every part. This is because a hologram doesn't store a picture like a photograph. It stores an interference pattern, a complex recording of how light waves scattered from an object interact with a reference beam. Pribram proposed that the brain operates on the same principle. Instead of storing memories in specific cells or synapses, the brain encodes experiences as intricate interference patterns in the neural fabric. A memory isn't a single file in a folder. It's a wave pattern spread across the vast network of the brain, which is why it's so resilient to damage. This elegantly explains neuroplasticity, the brain's ability to reorganize itself after injury. If one area is damaged, the information isn't lost. It can still be accessed from the remaining neural network, just as the entire image can be reconstructed from a fragment of the holographic plate. This is where David Bohm's work provides the cosmic context. Bohm, as we've discussed, proposed that the underlying nature of reality is an implicate order, a hidden, enfolded level of existence where everything is interconnected. The world we perceive, the explicate order, is an unfolded projection from this deeper reality. Pribram saw a stunning parallel. He suggested that the brain is a holographic decoder. It mathematically transforms the fuzzy, frequency-based information of the implicate order into the concrete, three-dimensional world of our everyday experience. In this view, your brain isn't generating consciousness. It is focusing it, much like a laser focuses coherent light to reconstruct an image from a hologram. It is filtering a universe of infinite potential into a manageable, coherent stream of perception. What we see, hear, and feel is not the raw data of the universe, but our brain's holographic interpretation of it. This model offers breathtaking explanations for phenomena that baffle conventional science. Consider near-death experiences. Individuals with no measurable brain activity, flatlined on an operating table, often report lucid, hyper-real experiences of floating above their bodies and moving through realms of light. From a standard medical perspective, this is impossible. No brain activity should mean no experience at all. But the holographic theory provides a compelling alternative. If the brain is a receiver and processor of consciousness rather than its source, then when the brain is shut down or impaired, the filter is removed. Instead of experiencing nothing, a person might experience a flood of unfiltered information from the implicate order, a direct encounter with the holographic source itself. The feeling of universal connectedness and overwhelming love commonly reported could be the subjective experience of tapping directly into the undivided whole from which our reality is projected. To grasp this, imagine your consciousness is like a lighthouse keeper in a dense fog. The lighthouse lens is your brain. It takes the omnipresent, diffuse white light and focuses it into a powerful, coherent beam that scans the surrounding waters, illuminating objects one at a time and creating a manageable view of the world. This is normal waking consciousness. Now, imagine the lighthouse lens suddenly shatters. Instead of being plunged into darkness, the keeper is suddenly surrounded by the full, unfiltered brilliance of the original light source, no longer constrained to a narrow beam. This could be analogous to what happens in an ND. The filtering mechanism fails, and consciousness expands to experience its true, unbounded nature. This theory doesn't just challenge our model of the brain, it revolutionizes our understanding of the mind itself, suggesting that our most intimate sense of self is not locked inside our heads, but is a non-local phenomenon that the brain simply interprets, inviting us to consider that we are not merely physical beings having a spiritual experience, but spiritual beings having a profound physical holographic adventure. Have you ever been absolutely certain of a memory, only to discover that the entire world disagrees with you? This unsettling experience is at the heart of a modern cultural phenomenon known as the Mandela Effect, where large groups of people share a vivid, detailed memory of something that, according to all available evidence, never happened. The name itself comes from one of the most famous examples. Countless individuals distinctly remember the South African leader Nelson Mandela dying in prison during the 1980s, complete with memories of news reports and a grieving widow. In reality, Mandela was released, became president, and passed away in 2013. This collective misremembering is so widespread and so emotionally charged for those who experience it that it has sparked a whirlwind of theories, pushing us to question not just the reliability of our own minds, but the very stability of reality itself. The most immediate and scientifically grounded explanation lies in the fallible nature of human memory. Psychologists point to concepts like confabulation, where our brains fill in gaps in our memory with plausible fabrications without any intention to deceive. We are storytelling creatures, and our memories are not perfect recordings but reconstructions, vulnerable to suggestion and distortion. Social reinforcement plays a huge role. When we hear others recount the same false memory, it strengthens our conviction that it must be true. A classic example is the misquotation from the Star Wars film The Empire Strikes Back. A vast number of people would swear on their lives that Darth Vader tells Luke Skywalker, "Luke, I am your father." Yet the actual line is simply, "No, I am your father." The more dramatic and iconic misquote is shared so often in popular culture that it overwrites the original in our mental archives. This is a clear case of collective false memory, where our internal narratives are edited and reshaped by external influences. However, for those who feel the visceral certainty of their alternate memories, standard psychological explanations can feel unsatisfying. This is where the phenomenon collides with some of the more fantastic theories we've explored. Could the Mandela Effect be a subtle glimpse into the mechanics of a quantum multiverse? In the many worlds interpretation, every decision branches off a new reality. The theory suggests that perhaps our consciousness isn't confined to a single timeline but occasionally, and perhaps unconsciously, flickers between closely aligned realities. In this view, the people who remember the Berenstain Bears books being spelled Barenstein aren't wrong. They may be tapping into a residual memory from a reality where it was indeed spelled that way. Their consciousness has, for a moment, brushed against a parallel world where that minor detail was different, leaving them with a powerful sense of cognitive dissonance when confronted with our world's spelling. It's as if we are all radio receivers and most of us are tuned to one station, but some people are picking up faint, overlapping signals from a station on a very similar frequency. This idea dovetails eerily well with the simulation hypothesis. If our reality is a sophisticated construct, akin to a cosmic video game, then the Mandela Effect could be interpreted as a glitch in the matrix. In any complex software, updates are deployed, code is changed, assets are replaced. What if the memories of the Berenstein bears or of the Monopoly man having a monocle he doesn't are not false memories, but residual data from a previous version of the simulation? We're remembering the old code before the latest patch was installed. Those who experience the effect could be unconsciously perceiving these minor inconsistencies in the rendering of our reality, a fleeting awareness of the digital scaffolding beneath the projected world. This transforms the Mandela Effect from a simple memory error into a potential clue about the programmed nature of our existence. Ultimately, the Mandela Effect sits at a fascinating crossroads between neuroscience, physics, and philosophy. It forces us to confront an uncomfortable truth. We cannot always trust our own minds, our memories, the very foundation of our identity and our understanding of the world, are malleable and imperfect. Yet, it also opens a door to breathtaking possibilities. Whether it's a quirk of psychology, evidence of branching timelines, or a signature of a simulated universe, this phenomenon profoundly blurs the line between objective reality and subjective experience. It challenges us to consider that the past might not be as fixed as we believe, and that our collective consciousness might be capable of perceiving a far richer and more complex reality than any single timeline could contain. But what if this power of the mind extends far beyond our own biology, reaching out to touch the very fabric of reality itself? This brings us to one of the most empowering and controversial ideas at the intersection of consciousness and physics, the concept that focused human intention might actively shape the physical world. We're moving beyond the brain influencing the body and into the realm of the mind potentially influencing matter, suggesting that we are not passive observers of a predetermined universe, but active participants in its ongoing creation. This isn't about magic or wishful thinking. It's a hypothesis that has been tested in rigorous laboratory settings, with results that continue to challenge a purely materialistic view of the cosmos. Some of the most compelling evidence for this comes from a long-term research project conducted at Princeton University's Engineering Anomalies Research Lab, known as PAIR. For nearly 3 decades, researchers there explored whether human intention could influence the output of machines known as random event generators. These are essentially electronic coin flippers, devices that produce a completely random sequence of ones and zeros, like the digital equivalent of constantly flipping a fair coin. The statistical output of these machines is, by definition, unpredictable and should average out to a 50-50 split over time. The PAIR experiments asked human operators to sit with these machines and, using nothing but their focused intention, try to mentally will the machine to produce more ones or more zeros. The results were staggering. Over millions of trials, a small but statistically significant deviation from randomness was consistently recorded. The operator's conscious intention appeared to be subtly biasing the machine's output, nudging chance itself in a desired direction. This effect was incredibly small, but it was real and repeatable, suggesting that consciousness and the physical world are not hermetically sealed off from one another, but exist in a delicate and interactive dance. This research has been championed and expanded upon by authors and researchers like Lynn McTaggart, who in her book, The Intention Experiment, synthesizes a vast body of scientific work arguing that directed thoughts can be a tangible force in the world. Her work, along with that of others like Deepak Chopra, who blends Eastern philosophy with quantum theory, proposes that intention operates through the interconnected quantum field. In this view, a focused thought isn't just a fleeting neurological event. It is a coherent pattern of energy and information that can resonate with and influence other energy patterns in the field, from the behavior of subatomic particles to the functioning of living organisms. Chopra often speaks of the quantum body, suggesting that at our most fundamental level, we are fields of intelligence and that our intentions can directly program these fields toward health, harmony, or specific outcomes. While these ideas push the boundaries of conventional science, they provide a theoretical framework for understanding how mind and matter might communicate. We don't have to look to quantum physics labs to see the potential power of intention in action. It's on display in every doctor's office through the well-documented placebo effect. When a patient is given a sugar pill but believes it is a powerful medicine, their body often produces a very real, measurable physiological healing response. Their belief and expectation, their intention to get better, triggers the release of endorphins, modulates the immune system, and reduces inflammation. This is not a psychological trick. It is the mind directly instructing the body to heal itself. The placebo effect demonstrates that our beliefs and intentions are not passive spectators to our biology. They are active regulators. If the intention to heal can overcome a diagnosed illness while believing in a sugar pill, it suggests that our internal state is a powerful determinant of our physical reality. This principle is harnessed deliberately in high-performance arenas like professional sports. Athletes have long used visualization, a form of focused intention, as a critical part of their training. A skier will mentally rehearse a complex downhill run hundreds of times, feeling every turn, every shift in balance, and every jump in their mind's eye before ever setting foot on the slope. Studies have shown that this mental practice activates the same neural pathways as physical practice, strengthening the brain's blueprints for those movements and significantly improving actual performance. The intention, vividly held in the mind, primes the body for flawless execution. Similarly, in the field of energy healing and meditation, practitioners focus intention to promote relaxation and healing in others, operating on the premise that a calm, directed mind can influence the energetic state of another person, helping to restore balance and well-being. All of this culminates in a profoundly empowering question. If intention truly holds this potential, how can we, as individuals, learn to cultivate and direct this ability more effectively in our own lives? It begins with moving beyond vague hoping and into the realm of clear, focused thought. A wish is a passive desire for something to happen, while an intention is an active alignment of one's mind and energy toward a specific outcome. Cultivating this skill involves practices that calm the mental chatter and increase focus, such as mindfulness meditation, which trains the brain to sustain attention on a single point. From that place of clarity, one can form a precise and emotionally charged intention, holding it in the mind with the same certainty as an athlete visualizing a perfect routine. It's about embodying the feeling of the desired outcome as if it is already present, thereby sending a coherent signal into the quantum field of possibilities. This idea transforms our role in the universe from that of a passenger on a predetermined ride to that of a co-creator, actively participating in the unfolding story of reality through the power of our conscious attention and purposeful thought. This perspective of a conscious, interconnected universe finds one of its most profound expressions in the concept of cosmic consciousness, the breathtaking idea that awareness is not confined to biological organisms, but is a fundamental, pervasive property of the cosmos itself. Imagine for a moment that the universe is not a vast, empty machine of inert matter and blind forces, but a living, thinking entity, a single, unified field of consciousness in which we are all participating. This is not a New Age fantasy. It is a hypothesis with deep roots in both ancient wisdom and modern science, suggesting that mind and cosmos are not separate, but are two aspects of a single, incredible reality. In this view, your individual awareness is not a lonely, isolated spark in a dark void. It is a localized expression of a universal mind, a wave rising from a boundless ocean of consciousness that encompasses all of existence. This transforms our understanding of reality from a cold, accidental cosmos to one that is inherently aware, intelligent, and alive. We can trace this powerful idea through several distinct but converging streams of thought. The visionary paleontologist and philosopher Pierre Teilhard de Chardin envisioned a kind of planetary thinking layer, which he called the noosphere. He saw this as the inevitable culmination of evolution, a global network of human thought and communication minds linking together through language, culture, and eventually technology that would coalesce into a unified planetary consciousness, a collective mind for the Earth. This noosphere would be the thinking cortex of the living planet, a new stage in evolution where consciousness becomes aware of itself on a global scale. Even more ancient and all-encompassing is the Hindu concept of Brahman, the ultimate, unchanging reality amidst and beyond the world, an infinite, impersonal consciousness that is the source and substance of all that exists. In this view, the myriad forms of the universe are merely the play of Brahman, the one consciousness appearing as many. Your true self, or Atman, is not separate from this cosmic consciousness. It is a spark of the divine fire, eternally one with the whole. These are not merely philosophical speculations. They are attempts to describe a direct, experiential truth reported by mystics and meditators across cultures and millennia. The direct realization that the sense of a separate self is an illusion and that their awareness is, in fact, coterminous with the awareness of the universe. This ancient intuition is finding a surprising resonance in some of the most cutting-edge theories of consciousness today. Modern Panpsychism, as we have discussed, proposes that consciousness is a fundamental property of all matter, from an electron to a human being. Cosmic consciousness takes this a step further, suggesting that these individual points of experience are not isolated, but are integrated into a larger, unified conscious field. A related scientific framework is integrated information theory, or IIT, developed by neuroscientist Giulio Tononi. IIT proposes that consciousness is identical to a system's capacity for integrated information, measured by a quantity called phi. The higher the phi, the more conscious a system is. While typically applied to brains, the theory is universal in principle. It opens the door to the possibility that any sufficiently complex and integrated system could possess some degree of consciousness, not just animals, but perhaps ecosystems, planets, or even the universe itself. If the cosmos has a high degree of causal integration and can process information in a unified way, then according to IIT, it would indeed be conscious. The universe would not simply contain consciousness, it would be consciousness experiencing itself through the vast, evolving tapestry of galaxies, stars, and living beings. We do not have to look to the stars to see hints of this cosmic self-regulation. We can see it at work on our own planet through the Gaia hypothesis, proposed by chemist James Lovelock and microbiologist Lynn Margulies. Gaia theory suggests that Earth itself functions as a single, self-regulating living system. The planet's biosphere, atmosphere, oceans, and geology are all tightly coupled in a complex dance that maintains conditions optimal for life. For instance, global temperature, the salinity of the oceans, and the composition of the atmosphere are all kept within a relatively narrow range despite massive external perturbations, such as increases in solar radiation over billions of years. This is not achieved through conscious intent, but through feedback loops that are almost intelligently designed. When carbon dioxide levels rise, plant growth increases to draw it down. When temperatures climb, phytoplankton release more cloud-seeding compounds to increase cloud cover and reflect sunlight. The entire system behaves with a coherence and purpose that looks remarkably like the physiological processes of a single organism, maintaining homeostasis on a planetary scale. While Gaia is not typically presented as a conscious entity, it powerfully illustrates how a system of countless individual parts can exhibit a unified, intelligent behavior that transcends its components, offering a compelling model for how a conscious cosmos might operate. This leads to one of the most awe-inspiring and practical questions we can ask. If the cosmos is in some way conscious, could we ever learn to communicate with it? This is not about sending a radio message to the stars and expecting a grammatical reply. It is about tuning in to a different kind of conversation, one based on resonance, pattern, and symbiosis rather than language. Indigenous cultures have long spoken of listening to the land, of understanding the messages carried by the wind, the behavior of animals, and the cycles of the seasons. This could be seen as a form of communication with a conscious planetary system. On an individual level, profound experiences of synchronicity, those meaningful coincidences that seem to defy mere chance, might be interpreted as moments where our individual consciousness briefly synchronizes with the larger pattern of the cosmic mind, receiving a nudge or an answer in the language of events. The feeling of overwhelming awe and connection when gazing at a starry night sky or standing in an ancient forest could be more than just an emotion. It could be a genuine, if fleeting, connection with that vast awareness, a moment of direct participation in the consciousness of the whole. This perspective does not diminish our scientific pursuit of knowledge. It enriches it, fostering a deep sense of unity, reverence, and responsibility. It suggests that we are not strangers in a strange land, but integral participants in a conscious universe, and that our journey of discovery is ultimately a journey of the universe coming to know and understand itself through us. Now, let's turn our gaze from the branching multiverse and the digital simulation to a concept that is at once terrifying and liberating, an idea that has haunted philosophy for centuries and finds eerie echoes in modern cosmology: the theory of eternal recurrence. First articulated with profound force by the German philosopher Friedrich Nietzsche, this is the notion that time is not a linear arrow but a vast, endless circle. The entire cosmos, in all its intricate detail, from the birth of the first star to the fall of the last leaf, will play out again and again, infinitely, with no variation whatsoever. Every joy, every pain, every triumph, and every mundane moment of your life has already happened countless times before, and will happen countless times again forever. Nietzsche presented this not as a scientific certainty, but as the ultimate thought experiment, a litmus test for the strength of one's spirit. He asked, what if a demon crept into your loneliest loneliness and said to you, "This life as you now live it and have lived it, you will have to live once more and innumerable times more, and there will be nothing new in it, but every pain and every joy and every thought and sight must return to you all in the same succession and sequence." Would you not throw yourself down and gnash your teeth and curse the demon? Or would you experience a moment of supreme affirmation, replying, "You are a god, and never have I heard anything more divine"? This philosophical vision of a cyclical cosmos finds a startling parallel in certain speculative models from modern physics. While the standard Big Bang model points to a single beginning and an eventual heat death or eternal expansion, other cosmological theories propose a universe that breathes. The idea of an oscillating universe suggests that the cosmos might undergo an endless series of big bangs and big crunches. After trillions of years, the expansion driven by dark energy could reverse, perhaps due to a property of dark energy itself that changes over time, and the entire universe would collapse back in a fiery, big crunch. This singularity could then rebound in a new Big Bang, giving birth to a new universe in an endless cycle of death and rebirth. A more modern variation, inspired by string theory, is cyclic cosmology, where our three-dimensional universe is a membrane, or brain, floating in a higher dimensional space. These brains could periodically collide, each collision creating the energy for a new Big Bang and setting off another cosmic cycle. In these models, the universe itself is caught in an eternal recurrence, though the laws of physics might be reset with each new cycle, making each iteration potentially different rather than an exact replica. This immediately plunges us into the most profound psychological and existential question of all. If everything repeats exactly, what happens to our consciousness? Would we be aware of the cycles, or would we relive each identical life completely unaware, like a character in a movie stuck on an endless loop? Most interpretations lean toward the latter. Your stream of awareness would be tied to the specific cycle you are in, with no memory of previous iterations. From your first-person perspective, life would feel exactly as it does now, linear, unique, and unfolding for the first and only time. The terrifying weight of eternity would be completely hidden from you. This is where the beautiful analogy of the film Groundhog Day is so powerful, yet also slightly misleading. In the film, the protagonist Phil Connors is acutely aware of his repetition. He retains his memories each day, allowing him to learn, grow, and eventually transform. Eternal recurrence, in its strictest Nietzschean sense, offers no such luxury. There is no learning curve across cycles because each cycle is a perfect, isolated copy. The growth and redemption must be achieved within the single iteration, with no knowledge of the infinite repetition that awaits. This leads directly to a fierce philosophical debate about meaning and freedom. If every action is predetermined to repeat infinitely, does that strip our lives of all meaning and negate free will? It can feel like the ultimate cosmic prison sentence, a fate worse than death because death at least offers an end. The French philosopher Albert Camus saw in this idea the epitome of the absurd, the human craving for meaning confronting a universe that offers only endless, pointless repetition. Yet Nietzsche intended it as the ultimate formula for affirmation. The point is not that you can change the future cycles, but that the very thought of eternal recurrence should force you to evaluate your present life with unbearable intensity. If you knew you would have to relive every single moment of your life exactly as it is forever, would you despair, or would you embrace it? The theory becomes imperative to live in such a way that you would welcome the infinite return of every moment. It challenges you to transform your attitude toward life itself, to find such profound joy and acceptance in your existence that the idea of its eternal return becomes a cause for ecstatic celebration rather than dread. It is the ultimate challenge to amor fati, the love of one's fate. This radically shifts the question from a speculative, what if, to a deeply practical, how then? If time loops eternally, how should we live? The answer is not to strive for some future reward or to change the unchangeable cycle, but to pour supreme significance into the present moment. Every choice, every action, every experience becomes infinitely weighted because it is not just happening once. It is etched into the eternal fabric of existence, destined to be relived forever. This knowledge, even as a thought experiment, can pull us out of complacency. It can make us more mindful, more passionate, and more courageous in crafting a life we could bear to live infinitely. It shatters the myth of linear progress, the idea that history is always marching forward to some better future. Instead, it suggests that meaning is not found at the end of the journey, but is woven into the quality of every single step we take, here and now. It asks us to live not for a destination, but to dance so beautifully in the moment that we would gladly dance the same dance for all eternity. What if your body could sense the future before your mind even has a chance to catch up? This isn't the premise of a science fiction novel. It's the startling claim at the heart of serious scientific research into precognition, the alleged ability to perceive or sense future events before they happen. While anecdotal accounts of premonitory dreams and gut feelings have existed for millennia, we are now beginning to see these mysterious experiences tested in controlled laboratory settings, with results that challenge our most fundamental understanding of time and causality. Imagine you're about to view a series of images on a computer screen. Most are calm, serene landscapes, but a few are randomly selected to be highly disturbing or shocking. As you sit there, sensors are monitoring your heart rate, skin conductance, and brain activity. In a series of controversial experiments conducted by researchers like Dean Radin at the Institute of Noetic Sciences, a bizarre pattern emerged. Test subjects began showing measurable physiological stress responses: a quickening heart, a spike in sweat gland activity, seconds before the disturbing image was randomly selected and displayed on the screen. Their bodies seemed to be reacting to the emotional content of the picture before the computer had even chosen it, as if they were unconsciously peeking a few moments into the future. This effect, dubbed presentiment, suggests that our nervous system might be wired to perceive not just the present, but to have a faint, intuitive reach into what is yet to come. These laboratory findings resonate powerfully with countless experiences from everyday life. Most of us have heard stories or perhaps felt it ourselves, that uncanny gut feeling that tells you not to board a specific flight, only to later discover it was delayed or had a close call. A driver suddenly slams on the brakes for no apparent reason, avoiding a child who darts into the street a second later. A parent wakes from a sound sleep with a feeling of dread, immediately calling a distant child only to find they are in the midst of a crisis. History is filled with such accounts. The famous story of Abraham Lincoln reportedly dreaming of his own assassination just days before it occurred is a classic example. While skeptics rightly point to confirmation bias, we remember the hits and forget the far more numerous misses. The sheer volume and visceral intensity of these anecdotes suggest there might be more at play than mere coincidence or selective memory. They point to a human capacity for intuitively sensing impending events that defies our linear model of time. So how could this possibly work? How can information from the future flow backward into the present? One compelling theoretical framework comes from the world of advanced physics, specifically from an interpretation of quantum mechanics known as time-symmetric or two-time theories. These theories, championed by physicists like John Cramer with his transactional interpretation, propose that quantum events are not one-way streets. In this model, when a particle interacts, offers are sent forward in time and confirmations are sent backward, creating a handshake across time that solidifies the event into reality. This process is not just a mathematical abstraction. It provides a potential physical mechanism for how a future event could send a faint echo or signal backward, a ripple in time that a sensitive conscious system might somehow detect. It implies that at the quantum level, the distinction between cause and effect might be far more fluid than we imagine, with the future potentially influencing the past just as much as the past influences the future. Another explanation moves beyond physics and into the nature of consciousness itself. If consciousness is non-local, not bound by the brain or the present moment, as theories like Panpsychism or the ideas of Bernardo Kastrup suggest, then accessing information from the future might not require sending a signal backward through time at all. Instead, a non-local consciousness would exist outside of the spacetime framework entirely. From this transcendent vantage point, the past, present, and future might all be equally accessible, like points on a map. In this view, precognition isn't about receiving a message from the future. It's about a part of our awareness momentarily tapping into a dimension where all time is present simultaneously. The future information was always there. Our conscious mind, which normally filters our perception to a narrow band called the present, simply managed to glimpse a broader view. This transforms precognition from a paranormal anomaly into a potential faculty of consciousness when it operates in a less constrained, more integrated state. This leads us to the most profound and disruptive question posed by these ideas. If precognition is real, even in a limited form, what does it do to our understanding of causality? The entire edifice of modern science is built on the principle that cause must precede effect. If effect can somehow precede cause, it threatens to unravel not just physics, but our entire logical conception of how the universe operates. One potential resolution is that precognition doesn't allow us to change a fixed future, but rather to perceive a probable future. In the many worlds interpretation of quantum mechanics, the future is a vast landscape of possibilities. A strong presentiment might be our consciousness perceiving the branch of reality we are most likely to actualize, giving us a chance to alter our course and choose a different path. The precognitive dream of a disaster could be a warning that allows us to steer away from that potential timeline, effectively causing the premonition to not come true in our experienced reality. This creates a fascinating loop where the future influences the present to prevent its own occurrence, a paradox that highlights the incredible complexity of a universe where time and consciousness are deeply intertwined. The very possibility of precognition forces us to consider that time may not be the linear, one-way river we perceive, but a far more mysterious and interactive medium, and that our minds might be capable of navigating its currents in ways we are only just beginning to imagine. We often think of space as the ultimate emptiness, a silent and passive void that simply separates one object from another. But what if this fundamental backdrop of our reality is not empty at all, but is instead a vibrant, dynamic field of consciousness itself? This is the breathtaking proposition put forward by a growing number of philosophers, scientists, and mystics. That space is the fundamental medium of mind, a cosmic ocean of awareness in which all things are immersed and interconnected. This idea finds a powerful voice in the work of systems philosopher Ervin Laszlo, who describes a fundamental information field that underlies all of reality, which he calls the Akashic field. This is not a New Age invention. The concept of Akasha is drawn from ancient Hindu and Vedic philosophies, where it is described as the primordial ether, the subtle, all-pervading substance that is the source of all matter and the record of all events. In this view, space is not a nothingness, it is the ultimate something, the source and the substance, the canvas and the painting, the silent witness and the active participant in the unfolding of the cosmos. This radical re-enchantment of the void finds a surprising resonance within the most advanced theories of modern physics. Quantum field theory tells us that what we perceive as empty space is actually a seething, bubbling foam of virtual particles constantly flashing in and out of existence, a phenomenon we know as zero-point energy or quantum foam. This isn't an inert stage, it's a dynamic, energetic plenum. Furthermore, fields are the fundamental entities of modern physics. The Higgs field, for instance, is an invisible energy field that permeates all of space and gives particles their mass. Think of it like an invisible, cosmic molasses that different particles wade through with varying difficulty. The ones that struggle the most against it acquire more mass. If such fields that dictate the properties of matter can exist throughout space, the theory of space as a conscious medium simply takes this a step further. It proposes that alongside the electromagnetic field and the Higgs field, there is a conscious field, a fundamental property of the universe that gives rise to subjective experience, just as the Higgs field gives rise to mass. In this model, individual consciousness, like yours and mine, is not generated by the brain in isolation. Instead, the brain acts more like a receiver or a transducer, a sophisticated antenna that tunes into and interprets this underlying field of spatial consciousness, translating a small portion of its vast intelligence into our personal stream of awareness. This perspective offers a stunningly elegant framework for understanding phenomena that have long been relegated to the fringes of science, such as telepathy or intuitive communication. If space itself is a conscious medium that connects all things, then the transfer of information from one mind to another wouldn't require a signal to travel through space, because the information would already be present within the spatial field itself. A powerful analogy is the internet. You can access a piece of information on a server halfway around the world almost instantly. The data isn't traveling to you through wires in a linear fashion. It's more accurate to say you are tuning into a field of information that exists everywhere at once, and your device is simply accessing a local node. In the same way, if spatial consciousness is a fundamental field, then your thoughts and experiences are not locked inside your skull. They are patterns within this field. Telepathy, then, might not be about sending a psychic message across a distance, but rather about two brains tuning their receivers to the same specific frequency within the conscious field, simultaneously accessing the same informational pattern. It's less like sending a letter and more like two radios being tuned to the same station. This leads to a truly awe-inspiring and practical question. If this conscious field exists, could we learn to consciously tune into it? Could we refine our internal receivers to access a broader bandwidth of this cosmic awareness? This is precisely what many ancient contemplative practices and modern consciousness exploration techniques seem designed to do. In deep meditation, the goal is often to quiet the incessant chatter of the individual mind, to lower the static on the receiver. When this is achieved, practitioners frequently report a profound sense of expansion, of merging with a larger, intelligent whole, of receiving insights and intuitions that feel like they come from beyond the individual self. This could be interpreted as the personal consciousness becoming less localized and more resonant with the foundational spatial consciousness from which it arises. It's not about gaining something new, but about removing the filters that normally limit our perception to a narrow, personal slice of reality. This idea transforms our relationship with the universe. The vast emptiness of space is no longer a cold, indifferent void to be feared, but a living, conscious plenum to be communed with. It re-enchants the cosmos, inviting us to see ourselves not as isolated spectators, but as integral participants in a universe that is not only alive but awake, aware, and deeply interconnected through the very fabric of space itself. Have you ever experienced a moment so perfectly timed and meaningful that it sent a shiver down your spine? Perhaps you were thinking of an old friend you hadn't seen in years, only for them to call you moments later. Or maybe you stumbled upon a book that contained the exact answer to a problem you had been wrestling with for weeks. These aren't just random accidents or simple coincidences. According to the pioneering psychiatrist Carl Jung, they might be glimpses into a deeper, hidden architecture of reality. Jung called these events synchronicities, which he defined as meaningful coincidences that occur with no apparent cause and effect relationship, yet seem to be connected by their significance to the observer. He proposed that these moments reveal a causal connecting principle, a fundamental layer of reality where the inner world of the mind and the outer world of matter are not separate, but intertwined aspects of a single, unified whole. In this view, the universe is not a cold, mechanical clockwork, but a living, meaningful tapestry where psyche and matter dance together in a mysterious harmony. To understand the profound strangeness of synchronicity, we must first distinguish it from ordinary coincidence. If you flip a coin and get heads 5 times in a row, that's a statistical coincidence. It might be unlikely, but it carries no personal meaning. A synchronistic event, however, is laden with significance. It feels purposeful, as if the universe is whispering a secret directly to you. Jung often worked with highly educated, rational patients who were stuck in their lives. He found that when he could not break through with analysis alone, a synchronistic event would often occur that was so powerful and personally relevant it would shatter their rigid worldview, opening them to new possibilities and healing. He believed these events were not caused by any known physical force but emerged from a deeper order of reality, which he called the unus mundus, or one world, a level of existence where the distinction between mind and matter dissolves. This idea of a hidden connection between consciousness and the physical world finds a startling echo in the bizarre realm of quantum physics, particularly in the phenomenon of quantum entanglement. As we've discussed, entangled particles can instantaneously influence each other's states across vast distances, defying our classical understanding of space and time. This spooky action at a distance, as Einstein called it, suggests that at its most fundamental level, the universe is non-local, deeply interconnected in a way that bypasses conventional cause and effect. Synchronicity appears to be a macroscopic, psychological version of this same principle. Just as 2 entangled particles remain mysteriously linked, a thought in your mind and an event in the external world can become entangled through meaning, momentarily revealing their underlying unity. It's as if the psychological and the physical are 2 sides of the same coin, and a synchronistic event is the rare moment when we see the edge of the coin, understanding that both sides are part of a single, inseparable object. The patterns of synchronicity also resonate deeply with the mathematical beauty of fractals, those infinitely complex shapes that are self-similar across different scales. A tiny twig resembles a branch which resembles the entire tree. In nature, we see this same pattern repeating in coastlines, clouds, and fern leaves. Synchronicity can be thought of as a fractal patterning of meaning, a small, seemingly insignificant event in your daily life, like seeing a specific number on a license plate, can mirror a much larger theme or pattern unfolding in your life, such as a major decision or a turning point. The external event and the internal psychological state are not causally related, but they are meaningfully similar, reflecting each other like a fractal pattern reflects itself across scale. This suggests that the universe may be organized not just by physical laws, but by principles of meaning and connection that express themselves in both our minds and the world around us, creating a cosmic symmetry that is more about resonance than force. We can find countless examples of this phenomenon in everyday life that feel too significant to dismiss as mere chance. A man decides to take a different route to work on a whim and ends up bumping into the person who will become his future business partner. A woman dreams of a rare type of bird and then sees that exact bird in her garden the next morning for the first time ever. You hear a forgotten song from your childhood on the radio at the very moment you are telling a story about it. These experiences are often dismissed as anecdotal, but their power lies in their subjective impact. They feel like a wink from the universe, a moment of grace that suggests our lives are part of a larger, more intelligent story than we normally perceive. They challenge the purely materialistic view of reality and open the door to a world that is responsive, meaningful, and perhaps even communicative. This naturally leads us to a profound and tantalizing question. Could these moments of synchronicity be subtle clues, hints from the universe that we are all part of a deeply interconnected and intelligent whole? Are they the fingerprints of a hidden order that usually operates just below the threshold of our perception, only revealing itself in these fleeting, meaningful glimpses? If so, then every synchronistic event is an invitation to look beyond the surface of things, to listen more deeply, and to consider that the separation we feel from the world around us might be the greatest illusion of all. These surprising alignments of inner and outer worlds hint at a cosmic harmony, a grand symphony where each of us is both a listener and a note, and where the music itself is the dance of a universe that is not only alive but also aware, constantly weaving the threads of matter and meaning into a single, breathtaking tapestry. Just when we thought we had uncovered all the possible phases of matter solids, liquids, gases, and even exotic plasmas, a discovery emerged so bizarre it seemed to defy the most fundamental laws of physics. Imagine a clock that ticks forever without ever being wound, a ring that spins perpetually without any push or input of energy. This is not a fantasy of perpetual motion. It is the reality of time crystals, a stunning new phase of matter that doesn't just exist in space, but dances in time, forever oscillating in a ground state of motion that challenges our deepest understanding of the universe's rules. The very concept feels like it was pulled from the pages of a science fiction novel, yet it represents one of the most exciting and mind-bending frontiers in modern physics, a place where time itself becomes a material property to be manipulated and studied. The story of time crystals begins with a theoretical spark from Nobel laureate physicist Frank Wilczek. In 2012, he posed a deceptively simple question: could there be a form of matter that is in its lowest energy state, yet still exhibits perpetual motion? This idea immediately raised eyebrows because it seems to directly violate one of the most sacred principles in physics, the second law of thermodynamics, which dictates that systems always move toward disorder and that perpetual motion machines are impossible. Wilczek wasn't proposing a machine that creates energy from nothing. He was imagining a new phase of matter whose inherent lowest energy structure is one of constant periodic motion. In a normal crystal, like a diamond, atoms are arranged in a repeating pattern that breaks the symmetry of space. The structure is the same if you move from one unit cell to the next, but it's not the same in all directions. Wilczek asked if a crystal could also break time symmetry. Could its structure be different at different points in time, even in its ground state, oscillating with a regular beat without any energy cost? The initial reaction from many in the physics community was deep skepticism, but the theoretical elegance was compelling enough to inspire a serious hunt for this strange new state. The breakthrough moved from theory to reality just a few years later, thanks to ingenious experiments conducted by teams at Harvard University and the University of Maryland. They didn't find these crystals lying around in nature. They had to engineer them under highly controlled conditions using complex quantum systems. In one landmark experiment, researchers took a chain of charged atoms called ions, trapped them with lasers, and then nudged them with a precise magnetic pulse to set them in motion. In any normal system, this motion would quickly dissipate due to friction and decoherence, like a ringing bell that eventually falls silent, but something astonishing happened. The chain of ions didn't settle down. Instead, it locked into a stable, persistent oscillation, flipping back and forth between two states at a regular interval. Crucially, this oscillation wasn't driven by the initial pulse. The pulse just revealed it. The system was oscillating in its ground state, the quantum equivalent of an object being as still as it can possibly be, yet still moving. This was the first definitive creation of a time crystal, a structure with broken time translation symmetry, meaning its state at time 1 is different from its state at time 2, even though no energy is being used to change it. This discovery of a phase of matter that oscillates without energy input isn't just a laboratory curiosity. It opens a portal to revolutionary technological applications, particularly in the field of quantum computing. One of the biggest obstacles to building a practical quantum computer is decoherence, the tendency of fragile quantum bits, or qubits, to lose their information due to the slightest disturbance from the outside environment. Their quantum superposition collapses and the computation fails. Time crystals, with their incredibly stable and protected periodic rhythm, could provide a solution. Imagine a time crystal acting as a perfect natural clock inside a quantum computer, its unwavering oscillation providing a stable reference to help synchronize qubits and shield them from external noise. This could dramatically extend the coherence time of qubits, making quantum computations far more reliable and powerful. Beyond computing, time crystals could lead to unimaginably precise sensors and gyroscopes, or form the heart of clocks that are orders of magnitude more accurate than today's atomic clocks, potentially redefining the very standard of a second. Perhaps the most speculative and fascinating connection lies not in technology but in biology and consciousness. Our brains are not static organs, they hum with rhythmic electrical activity. Brainwaves alpha, beta, gamma, delta are oscillations that correlate with different states of awareness, from deep sleep to focused concentration. Some neuroscientists have begun to wonder if certain neural networks in the brain could exhibit properties analogous to time crystals. Could the persistent, self-sustaining rhythms that govern our sleep-wake cycles or our focus be related to this same broken time symmetry? It's a profound leap, but it invites us to consider that the principles allowing a time crystal to tick forever in a lab might also be at work in the organic machinery of our minds, providing a stable temporal structure for consciousness itself. This would suggest that the eternal dance of time crystals is not just a property of cold, trapped ions, but a fundamental physical principle that might even underpin the rhythmic pulse of awareness. Frank Wilczek himself captured the wondrous implications of this discovery, reflecting that time crystals show that nature can produce mechanisms that are natural timekeepers. This statement points to a reality far stranger and more beautiful than we imagined, where time is not just a parameter in an equation but can be embodied in the very structure of matter. The existence of time crystals forces us to expand our definition of what matter is and what it can do, blurring the line between the static and the dynamic, between energy and motion. So, could these bizarre structures help us finally harness time itself? While we are not building time machines, we are learning to craft materials that treat time as a dimension of their being, offering a form of control over temporal processes that was once the realm of pure fantasy. This innovation does more than merge time and material science. It unveils a new axis of existence for exploration, suggesting that the universe holds layers of subtlety and wonder we are only just beginning to perceive. For all our exploration of external realities and cosmic theories, perhaps the most profound mystery lies not in the stars, but in the very nature of our own perception. We navigate the world through a fundamental division, a split that feels as natural as breathing, the subject here inside our heads, observing an external world of objects out there. This sense of being a separate self, a distinct observer in a universe of observed things, is the bedrock of our everyday experience. Yet, across millennia and cultures, a radically different understanding has been consistently reported by mystics, sages, and those who have touched the deepest layers of human awareness. This is the concept of non-duality, the direct realization that consciousness and reality are not two separate things, but a single, unified, and indivisible whole. It is the stunning revelation that the subject-object split is the ultimate illusion, a convincing veil woven by the mind that obscures a far more fundamental unity. This perspective is the cornerstone of several of the world's most profound spiritual traditions. In the philosophy of Advaita Vedanta, a school of Hindu thought, the entire manifest universe is seen as an appearance within a single, ultimate reality called Brahman, which is pure, undifferentiated consciousness. The individual self, or Atman, is not a separate entity but is, in its truest essence, identical to Brahman. The core teaching, Tat Tvam Asi, or Thou Art That, is a powerful declaration that your deepest self is not the limited ego, but the boundless, eternal consciousness that is the source and substance of all that is. Similarly, Zen Buddhism relentlessly points to the direct experience of non-duality, cutting through conceptual thinking to reveal a state of suchness, where the seer and the seen are one. The famous koan, "What is the sound of one hand clapping?" is not a riddle to be solved intellectually, but a tool to shatter the dualistic mind, to force awareness to a point where the question itself dissolves into a silent, unified knowing. These are not philosophical beliefs to be adopted, but experiential truths to be realized, pointing toward a mode of perception that transcends the ordinary subject-object framework. This ancient wisdom finds a startling and unexpected resonance in the most cutting-edge theories of modern physics. The holographic principle, which suggests our three-dimensional reality is a projection from a two-dimensional surface, implies that the separateness of objects is an emergent property, not a fundamental one. At the deeper level of the implicate order, all is interconnected and whole. Even more compelling is the phenomenon of quantum non-locality, where entangled particles behave as a single system regardless of the distance between them, defying our classical notion of isolated objects in space. This profound interconnectedness at the heart of matter mirrors the non-dual insight of interconnectedness at the heart of consciousness. It's as if physics, in its own mathematical language, is describing the same unified reality that mystics have experienced directly for centuries. The universe described by quantum mechanics is not a collection of separate billiard balls bumping into each other. It is a seamless web of relations, a dynamic whole where the act of observation is inseparable from the thing observed. Science and spirituality, from their vastly different paths, seem to be converging on the same breathtaking conclusion that at its core, reality is one. The most compelling evidence for non-dual awareness comes not from theory, but from direct experience. Those who have undergone profound mystical states, often through deep meditation, near-death experiences, or spontaneous awakenings, describe a dramatic dissolution of the sense of a separate self. The boundary between the perceiver and the perceived simply vanishes. A person gazing at a mountain no longer feels like a separate self looking at an external object. Instead, there is just the experience of mountain-ing, a unified field of awareness in which the form of the mountain arises. The feeling is often described as one of boundless expansion, infinite peace, and a love that is not personal but universal. In this state, the individual ego is seen for what it is, a useful construct for navigating the practical world, but not the ultimate truth of who we are. It is a temporary pattern of thought and memory, a story we tell ourselves, superimposed upon the eternal, silent background of pure awareness that is our true nature. This is not an experience of becoming one with everything. It is the realization that you already are everything, and that the feeling of separation was the illusion all along. This realization inevitably forces upon us the most intimate and disorienting question imaginable. If all is one, then what or who am I? What is the nature of this individual self that I have taken myself to be for my entire life? The non-dual perspective offers a radical answer. The individual self is not a thing, but a process. It is a vortex of thoughts, sensations, memories, and emotions that arise and pass away within the vast, open space of awareness itself. We mistakenly identify with this constantly changing stream, believing it to be a solid, separate entity called me. But just as a wave is not separate from the ocean, it is a temporary formation of the ocean. The individual self is not separate from consciousness. It is a temporary modulation of consciousness. Your true identity is not the content of your experience, but the context in which all experience appears. You are not the thought, but the awareness that knows the thought. You are not the feeling, but the space in which the feeling arises and subsides. This is not an annihilation of the person, but a profound liberation from the confines of a limited identity, revealing that your essential being is the same timeless, aware presence that underlies all of existence. This understanding transcends ordinary perception, not by adding something new, but by subtracting the illusion of separation, revealing a unity that was there all along, hidden in plain sight. What if death is not an end, but a branching point, a moment where your consciousness simply steps into a parallel existence where you survive? This is the startling and deeply unsettling proposition at the heart of quantum immortality, a thought experiment that emerges directly from the many worlds interpretation of quantum mechanics. It suggests that from a first-person perspective, you might be essentially impossible to kill, not because your body becomes invincible, but because your stream of awareness will always follow a path through the multiverse where you continue to exist. This isn't about achieving eternal life in a single timeline. It's the idea that your subjective experience is tethered to the branches of reality where you are still alive, no matter how improbable those branches may be. This bizarre concept is most famously illustrated by the quantum suicide thought experiment. Imagine a scenario where a volunteer is placed in front of a gun, rigged to a quantum measuring device. The trigger is tied to the spin of a subatomic particle. If the particle's spin is measured as up, the gun fires. If it's down, it doesn't. According to the Copenhagen interpretation, there's a 50% chance the experimenter finds a live subject and a 50% chance they find a corpse after the first measurement. But the many worlds interpretation tells a different story. It says that at the moment of measurement, the universe splits. In one branch, the particle is spin up, the gun fires, and the volunteer dies. In the other, perfectly real branch, the particle is spin down, the gun clicks empty, and the volunteer lives. Now, repeat the experiment. After 100 iterations from the perspective of an outside observer, there are countless branches where the volunteer is long dead. But from the volunteer's own subjective perspective, they can only ever experience the sequences of events where the gun repeatedly fails to fire. They would find themselves alive after 1,000, 1 million, or 1 billion attempts, each successful click feeling like an astronomically unlikely miracle to them, while countless versions of themselves perish in unseen branches. Their consciousness never experiences termination. It only follows the path of continuous existence. This theory inevitably draws a fascinating parallel to numerous reports of near-death experiences. Many individuals who have been clinically dead and revived describe a common narrative, floating above their bodies, moving through a tunnel toward a loving light, and experiencing a profound life review. The standard scientific explanation often points to physiological causes like oxygen deprivation or a flood of neurotransmitters. However, quantum immortality offers a radically different, albeit highly speculative, interpretation. Could these experiences be the conscious mind's transition between timelines? In the moment of death in one universe, does awareness seamlessly transfer to the nearest adjacent branch where the body survives the trauma? The feeling of peace and detachment could be the subjective experience of this quantum jump, a brief disconnection from one physical vessel before reintegrating with another. This could even provide a potential scientific framework for reincarnation beliefs found in many cultures. Rather than a soul migrating to a new body after death, it might be a single, continuous consciousness navigating an infinite tree of possible lives, each one a different branch of its own potential existence, with the illusion of linear rebirth being our limited way of perceiving this complex, multidimensional journey. This leads us into a thorny ethical and philosophical thicket. If quantum immortality is true, even as a theoretical possibility, it presents a terrifying form of solitude. Everyone you have ever known and loved would, from your perspective, eventually die. You would be forced to witness the end of worlds, the death of stars, and the heat death of the universe in one long, unbroken chain of consciousness, always jumping to the branch where you persist. You would become the ultimate observer, trapped in a cosmic destiny where death is an experience that only happens to other people, to other versions of you. This raises a disturbing question about the nature of suffering. Would a person with a terminal illness ever experience their own death? Or would their consciousness always find a branch where an unexpected remission occurs, or a new treatment is discovered at the last possible second? The theory suggests that from the inside, you might never experience your own final moment, making death an illusion for the one thing that matters, your subjective awareness. This forces a profound and personal challenge. The theory is, by its very nature, untestable from an outside perspective. Any test would only produce a result for the observer. But could you ever risk testing it on yourself? The thought experiment becomes a terrifying personal gamble. To even consider it requires a faith in the many worlds interpretation so absolute that you would bet your life on it, or rather, bet that you have an infinite number of lives to lose. This is not an experiment for the faint of heart. It is a philosophical leap into the abyss, forcing us to confront what we truly believe about the nature of reality, consciousness, and the finality of our own existence. Quantum immortality doesn't promise heaven or paradise. It offers a bizarre, lonely, and potentially agonizing form of eternity, challenging us to consider whether endless existence is a blessing or the ultimate curse. Look at a fern leaf, a snowflake, or the branching pattern of a tree against the sky. Now look at an image of the human brain's neural network or the intricate web of blood vessels in your own body. You will see the same pattern repeating itself at different scales, a characteristic of fractals, those infinitely complex shapes that are self-similar across magnification. This is no mere coincidence. These patterns, discovered and named by mathematician Benoit Mandelbrot, appear to be a fundamental architectural principle of the universe, from the grandest galaxy clusters to the smallest quantum fluctuations. But what if this same principle doesn't just organize matter, but also mind? What if consciousness itself operates on a fractal pattern, revealing a deep, hidden connectivity between our inner world and the cosmos? The connection becomes startlingly clear when we peer inside the human brain. Neuroscience has revealed that the brain is a masterpiece of fractal engineering. The branching structures of neurons, the way capillaries supply blood, and even the electrical activity of the brain itself all exhibit fractal properties. This isn't an aesthetic accident, it's a mark of incredible efficiency. A fractal structure allows for the maximum surface area and connectivity within a limited three-dimensional space, enabling the roughly 86 billion neurons in your brain to form an estimated 100 trillion connections. This fractal organization is what allows for such immense complexity to emerge from a relatively small volume, but it goes deeper than just structure. The actual electrical oscillations of the brain waves we measure as alpha, beta, theta, and gamma rhythms, also display fractal dynamics. This means the patterns of neural activity, the very language of thought, are self-similar over time. A millisecond of brain activity mirrors the pattern of a minute, which mirrors the pattern of an hour. This suggests that the processes of thought, memory, and perception are not linear and separate, but are woven together in a continuous, nested fractal tapestry. This leads to a fascinating theory that consciousness itself might have a fractal nature. Just as a fractal pattern contains the whole in each of its parts, could each moment of awareness contain the essence of the entire conscious field? Think about the flow of your own thoughts. One moment you are thinking about a specific task, but within that thought are echoes of your broader goals, your emotional state, and your entire history. Your mind doesn't operate in isolated compartments. It's a hierarchy where each level of thought is both a whole in itself and a part of a larger whole. This fractal nature of thought could explain the incredible richness and depth of our inner experience, where a single sensation or memory can unfold into a vast network of associations and meanings. It suggests that consciousness is not a simple on-off switch but a spectrum of depth and complexity, with simpler forms of awareness nesting within more complex ones, all following the same basic pattern. We can find experiential evidence for this in practices like meditation. Advanced meditators often report states where the normal chatter of the mind quietens and awareness expands into a field of pure, silent observation. In this state, the content of thought may fall away, but the pattern of awareness itself remains a self-similar, ever-present witnessing that feels the same whether it lasts for a second or an hour. It is a timeless, spacious quality that seems to be a fundamental feature of consciousness, regardless of scale. This meditative state could be seen as tapping into the base fractal pattern of awareness itself, before it gets cluttered with the specific content of thoughts and sensations. It's like perceiving the mathematical formula that generates the intricate Mandelbrot set, rather than getting lost in the endless details of its zooming patterns. This experience hints that beneath the surface activity of the mind, there is a fundamental, fractal order to consciousness that is stable, coherent, and deeply interconnected. So what does this universal presence of fractals ultimately reveal? It points toward a cosmos that is not random or chaotic, but organized by deeply embedded principles of order and self-organization. The same mathematical rules that govern the formation of a mountain range also govern the firing of your neurons and the flow of your thoughts. This isn't necessarily proof of a conscious universe, but it is compelling evidence for a deeply coherent and connected universe, one where the boundary between the inner world of mind and the outer world of nature is far more permeable than we might have assumed. The fractal patterns suggest that the universe operates through a language of iteration and self-similarity, and that our own consciousness is a beautiful, complex expression of that same cosmic language. This invites us to consider a truly awe-inspiring possibility, that by turning our awareness inward and exploring the depths of our own minds, we might not be exploring something separate from the universe, but rather, we might be tuning into the very patterns that the universe uses to build itself, discovering that the cosmos has, in a very real sense, patterned its own awareness after itself. But what if the very essence of who you are could be disassembled in one location and perfectly reconstructed in another, instantaneously traversing any distance in the blink of an eye? This is the tantalizing promise of teleportation, a concept that has leapt from the pages of science fiction into the rigorous laboratories of quantum physicists. While we are not beaming people across continents just yet, the teleportation of information, the quantum state of a particle, is not only possible but has already been achieved. This incredible feat relies on two of the most bizarre properties in the quantum toolkit: entanglement and tunneling. Quantum entanglement, as we've explored, creates an instantaneous link between particles, a ghostly connection that defies space. Quantum tunneling is equally strange, allowing a particle to seemingly vanish on one side of an impenetrable barrier and reappear on the other, as if it found a secret passage through the mountain rather than climbing over it. It doesn't actually punch a hole. It's more like the particle's wave function has a finite probability of existing on the other side, and it effectively samples that possibility, vanishing and reappearing in a probabilistic jump. These phenomena form the bedrock of quantum information teleportation. Here's how it works in practice. Scientists take a pair of entangled particles. One stays put while the other is sent to a distant location. A third particle, carrying the quantum information to be teleported, is then measured together with the local entangled particle. This measurement instantly alters the state of the distant, entangled partner, effectively transferring the information across the vast distance without anything physical ever traveling through the intervening space. The original quantum state is destroyed in the process, adhering to the no-cloning theorem, which forbids the perfect copying of a quantum state. As pioneering physicist Charles Bennett, who first proposed the protocol in 1993, eloquently put it, "It's not that the particle is being faxed, it's more like the original is being burned in the process of creating a perfect replica elsewhere." This successful teleportation of information inevitably sparks the monumental question: could this ever be scaled up to teleport a human being? The technical challenges are almost unimaginable. It would require scanning and precisely measuring the quantum state of every single atom in your body, a number in the order of 10 to the power of 28, and then transmitting that incomprehensibly vast amount of information to a receiver that would need to reassemble you perfectly from a local reservoir of atoms. The energy and computational power required are far beyond any technology we can conceive of today. But beyond the technical hurdles lies a far deeper, more philosophical problem that strikes at the very heart of our identity. The standard quantum teleportation protocol is a destructive process. The original is annihilated, so if a human were teleported, the you that steps into the machine would be disintegrated. An exact replica, believing itself to be you with all your memories and feelings, would materialize at the destination. But is that replica truly you, or is it merely a perfect copy while the original, conscious you ceases to exist in a flash of disintegration? This is the classic teletransportation paradox that philosophers have wrestled with for decades, and it becomes terrifyingly real when considered through a quantum lens. Science fiction has long grappled with these chilling identity issues, providing us with powerful narratives to explore the consequences. The film The Prestige offers a stark and horrifying illustration. In it, a magician uses a teleportation device to create a perfect duplicate of himself across the room. But each time he does so, the original version is trapped and drowned in a water tank beneath the stage. The man who takes the bow night after night is always the copy, living with the horrific knowledge that his success is built on the repeated murder of his former self. While this is a dramatic fiction, it highlights the central ethical nightmare of destructive teleportation. From an external perspective, it works flawlessly, but from the first-person perspective of the original, it is indistinguishable from suicide. Another classic example is Star Trek's transporter. The franchise famously hand-waves the problem with the concept of a pattern buffer, but even there, episodes like Second Chances confront the issue directly when a transporter malfunction creates two identical Commander Rikers, both with an equal claim to being the original, forcing them to build separate lives. This forces us to confront the most intimate question we can ask ourselves: what is the fundamental nature of the self? If your consciousness is purely the product of the specific arrangement of atoms and the information they encode, then a perfect replica would indeed be you in every meaningful way. It would wake up convinced it had just been teleported, with all your memories, loves, and regrets intact. But if consciousness is something more, if it has a qualitative, subjective aspect that is not just information but a unique, continuous thread of experience, then the destruction of the original brain would snap that thread forever. The copy might be a perfect doppelganger, but its conscious experience would be a new one, beginning at the moment of its creation, leaving the original you truly dead. This dilemma becomes even more acute if we consider that our bodies are not static. We are constantly shedding atoms and replacing them over time. The you of today is materially different from the you of 7 years ago, yet you feel a continuous sense of self. This suggests that identity is tied to the pattern of information, not the specific particles. But is the teleporter copying the pattern, or is it moving a continuous stream of consciousness? The answer to that question will determine whether teleportation is the ultimate mode of travel or the most sophisticated suicide Booth ever devised. The technology, should it ever become possible, doesn't just challenge our notions of travel. It forces a profound re-examination of what it means to be, to persist, and to be an individual in a universe where the self might just be a pattern of information waiting to be copied, transferred, and perhaps tragically erased. Imagine a future where death is not an end, but a transition where your mind, your memories, your very essence could be carefully extracted from its biological vessel and transferred to an advanced digital substrate, granting you a form of immortality within a vast computational realm. This is the audacious goal of mind uploading, a concept that pushes the very boundaries of what it means to be human, blurring the lines between biology and technology in ways that are both thrilling and deeply unsettling. The technological hurdles to achieving this are, to put it mildly, monumental. The human brain is the most complex object we know of in the universe, a network of nearly 90 billion neurons connected by over 100 trillion synapses, each connection dynamic and constantly changing. To upload a mind, we would first need to map this staggering complexity in exquisitely precise detail. One proposed method is whole brain emulation, which would involve scanning the entire structure of a preserved brain, perhaps by slicing it into impossibly thin layers and imaging each one with nanometer precision using advanced electron microscopes. The resulting dataset, a digital replica of the brain's connectome's wiring diagram, would then be run on a computer powerful enough to simulate the electrochemical dance of every neuron and synapse. The computational power required is almost unimaginable, likely requiring quantum computers or systems we haven't even conceived of yet. Beyond the sheer data and processing needs, we face the challenge of accurately simulating the brain's environment. The brain is not an isolated computer. It is deeply embodied, constantly receiving and responding to a flood of sensory input from the body and the outside world. A convincing simulation would need to provide an equally rich and dynamic digital environment for the uploaded mind to interact with, or risk it descending into a state of sensory deprivation or madness. This leads us directly to the most profound and unanswerable philosophical question at the heart of this endeavor. If you successfully create a digital copy of a brain, have you transferred a consciousness, or have you merely created a copy? Would the upload be you experiencing a new digital existence, or would it be a sophisticated doppelganger, a new consciousness that has all your memories and believes itself to be you, while the original, biological you remains right where it is, facing eventual death? This is the classic ship of Theseus problem applied to the self. If you replace every part of a ship, is it still the same ship? If you slowly replace your biological neurons with synthetic analogs in a process called gradual replacement, you might maintain a continuous stream of consciousness, making the transition feel more authentic. But if the upload is done destructively by scanning and then terminating the original brain, the question becomes terrifyingly personal. From the perspective of everyone else, the upload is you. It will talk like you, remember your childhood, and love your family. But from your first-person perspective, the moment of destruction is the end. Your subjective experience ceases, and a new entity, a perfect copy, wakes up in a machine. This isn't a glitch, it's a fundamental feature of copying information. The original is always the original. Futurists like Ray Kurzweil passionately envision a future where this is not only possible but desirable, a key step in the coming singularity, where human and machine intelligence merge. He predicts that by scanning our brains from the inside using swarms of nanobots, we will be able to back up our minds and live on in virtual paradises, free from the frailties of the flesh. Yet, even if the technology were perfected, the ethical and identity questions would remain. Would an uploaded mind have the same rights as a biological human? Could it be turned off, or would that be murder? Could it be copied, creating multiple versions of the same person, and which one would be the real you? We are already taking the first tentative steps toward this future with modern brain-computer interfaces. Devices like Neuralinks are learning to decode neural signals, allowing paralyzed individuals to control robotic limbs or type on a screen with their thoughts. These are crude compared to a full upload, but they represent the beginning of a direct dialogue between the wetware of the brain and the hardware of computers. They demonstrate that we can interpret the brain's language, at least on a basic level. Each breakthrough brings us closer to the possibility of not just reading signals, but of writing them back, of feeding a simulated reality directly into the neural cortex. The ultimate goal of such research is a seamless merger, a future where our minds can inhabit and control digital avatars as effortlessly as we control our physical bodies. This frontier forces us to confront the possibility that consciousness might not be a magical essence, but a specific type of information processing, a pattern that can, in theory, be run on any sufficiently powerful computer, whether it's made of carbon-based cells or silicon chips. So the final, deeply personal question remains: if the technology were safe, reliable, and available to you, would you choose to upload your mind? Would you trade your mortal body for a potentially eternal digital existence, even if it meant that the you that steps into the scanner might never step out, replaced by a perfect digital twin who gets to live forever? This is the ultimate gamble on the nature of the self, a choice that hinges on whether you believe you are the unique, continuous thread of your subjective experience, or simply the beautiful, complex pattern of information that thread has woven. If black holes are the universe's ultimate cosmic drains, sucking in everything that crosses their event horizon, then their theoretical opposites would be the universe's fountains, spewing out matter and energy in a brilliant, explosive reversal of time itself. These hypothetical objects are known as white holes, and while they have never been observed, they emerge as a beautiful and tantalizing mathematical possibility, from the very same equations of general relativity that predict black holes. Imagine hitting the rewind button on a black hole's life cycle. Instead of a star collapsing inward under its own gravity, you would see a miraculous eruption of light and matter from a single point, an event that cannot be entered from the outside, only exited. It's the ultimate cosmic do not enter sign, a one-way door leading out of a hidden region of space-time. This stunning symmetry is what makes white holes so compelling to physicists like Carlo Rovelli, who has pondered their potential role in the cosmos. He suggests that while they may not exist in a stable, long-lasting form, they could represent a fleeting phase in the life of the universe, a momentary burst of creation that hints at a deeper order beneath the apparent irreversibility of time. The potential cosmological roles for white holes are as grand as they are speculative. One of the most mind-bending ideas is that the Big Bang itself could have been a white hole event. Think about it, our universe erupted from an unimaginably dense and hot singularity, expanding outward and creating all the space, time, and matter we see today. This sounds remarkably similar to the definition of a white hole, a point of origin that cannot be re-entered, from which all existence flows. In this view, our entire cosmos isn't just in a universe, it is the expanding output of a primordial white hole. This provides a potential alternative to the idea of a singular beginning from nothing, suggesting instead a bridge from a previous state of reality, perhaps even a collapsed universe from another dimension or a different part of the cosmic manifold. On the opposite end of time, white holes could also offer a bizarre vision of an ending. If our universe continues to expand forever, eventually fading into a cold, dark emptiness in a scenario known as heat death, some theories suggest that quantum effects could cause a universal rebound. The entire cosmos could undergo a quantum tunneling event, instantly transforming from a state of maximum entropy into a new white hole, birthing an entirely new universe from the ashes of our own. This paints a picture of an eternal cycle, a cosmic phoenix where death and rebirth are woven into the very fabric of physics. This profound symmetry between birth and death, entrance and exit, inevitably draws our inquiry back to the nature of consciousness and the subjective flow of time. If white holes represent a reversal of time's arrow on a cosmic scale, could there be a parallel process within the mind? We experience time as a relentless forward march, with memory firmly anchored in the past and perception locked in the present. But what if, under certain extraordinary conditions, this flow could be disrupted or even reversed? Consider the bizarre neurological phenomenon of retroactive memory, where a later event seems to alter the recollection of an earlier one, almost as if the memory is being rewritten backward in time. Or the disorienting experience of a potent déjà vu, which can feel less like a glitch and more like a momentary overlap of two different timelines. In the context of white holes, these could be seen as microscopic echoes of a macroscopic time reversal principle. If the universe allows for regions where gravity and time operate in reverse, then perhaps the brain, as a complex physical system operating within that universe, possesses latent pathways for information to flow backward through its neural networks. This isn't about literally remembering the future, but about the mind's internal timeline exhibiting a fluidity that mirrors the strange symmetries of relativistic physics. To make this abstract concept more tangible, consider the simple analogy of rewinding a video. When you rewind a film, the events play out in reverse. Smoke pours back into a gun, a shattered vase reassembles itself, and a diver soars backward from the water onto the diving board. A white hole can be thought of as a natural, cosmic version of this rewind. Now, apply that same concept to the stream of consciousness. What would it be like to rewind your own memories? Instead of remembering a conversation from yesterday, you would experience it unfolding in reverse. the words unsaid in perfect order until the memory returns to its starting point. While this sounds like pure fantasy, it challenges our assumption that the arrow of time in the mind is an absolute law, suggesting instead that it might be a powerful, biologically enforced habit that could, in theory, be broken. The existence of white holes as a mathematical reality expands the realm of the possible, inviting us to consider that the forward direction of time we hold so dear might not be a fundamental rule, but merely the most probable and stable configuration in our particular corner of reality. This realization doesn't just solve a puzzle in theoretical physics. It adds a layer of profound beauty to our understanding of existence, revealing a cosmos built not on rigid, one-way streets, but on elegant, symmetrical principles that hint at a reality far more fluid and interconnected than our everyday experience would ever suggest. While we often think of our minds as isolated fortresses, private and unique to each of us, what if the deepest layers of our psyche are not personal at all, but are instead a shared inheritance, a vast, common reservoir of experience that connects all of humanity? This is the revolutionary concept proposed by the Swiss psychiatrist Carl Jung, the collective unconscious. Jung noticed that his patients, from all walks of life and cultural backgrounds, often dreamed of similar figures and symbols: the wise old man, the nurturing mother, the hero, the trickster. These weren't drawn from their personal experiences. They felt ancient, universal, and strangely familiar. He concluded that beneath our personal unconscious, which contains our repressed memories and forgotten experiences, lies a much deeper stratum of the psyche. This collective unconscious is not developed individually. We are born with it. It is a shared psychic inheritance, a universal library of human experience that contains the fundamental, instinctual patterns of behavior and perception that have been repeated across millennia. Jung called these deep-seated patterns archetypes. They are not fully formed images, but rather innate predispositions, the psychic equivalent of the hardwired instincts that guide animal behavior. An archetype is like the deep bed of a river, shaping the flow of water, while the specific content of our lives and cultures is the water itself, the unique manifestation of that underlying form. This theory finds breathtaking expression in the common myths and stories that emerge independently across the globe, stories that seem to be written from the same deep psychological script. Consider the hero's journey, an archetypal pattern identified by mythologist Joseph Campbell. From the Epic of Gilgamesh in ancient Mesopotamia to the story of Moses in the Hebrew Bible, from the quests of King Arthur in Celtic legend to the adventures of Luke Skywalker in a galaxy far, far away, the core narrative remains strikingly consistent. A hero receives a call to adventure, crosses a threshold into an unknown world, faces trials and allies, undergoes a supreme ordeal, seizes a reward or elixir, and returns home transformed, ready to bestow that boon upon their community. These stories were not copied from one another. They sprang up in cultural isolation. Jung would argue they all bubbled up from the same deep well, the collective unconscious, using the archetype of the hero to express a universal human process of growth, struggle, and self-discovery. We see the same with the archetype of the Great Mother, manifesting as the nurturing, life-giving goddesses like Isis in Egypt, Demeter in Greece, or Tara in Buddhism, representing fertility, nourishment, and the cycle of life and death. These universal themes suggest a shared psychic bedrock upon which all human cultures build their unique symbolic worlds. This idea of a shared, non-physical realm of information naturally invites connections to other theories we've explored. The concept of morphic fields proposed by Rupert Sheldrake acts as a potential scientific counterpart to Jung's philosophical framework. Sheldrake's fields are non-physical patterns that guide the form and behavior of natural systems, becoming stronger through repetition. The collective unconscious could be seen as a specific type of morphic field, a psychic morphic field that has been shaped and strengthened by the repeated experiences of countless human beings throughout history. Just as a morphic field for a crystal structure makes it easier for that crystal to form anywhere in the world, the archetypal fields of the collective unconscious make certain myths, symbols, and patterns of behavior more likely to emerge in any human mind, anywhere. This provides a potential mechanism for how archetypal information could be transmitted, not through genes or culture, but through resonance with these formative fields. Even more compelling is the potential link to the non-locality of quantum physics. Quantum entanglement demonstrates that particles can be instantaneously connected across any distance, behaving as a single system and defying our classical understanding of separate objects in space. If consciousness itself has a non-local aspect, as some interpretations of quantum theory suggest, then the collective unconscious could be understood as a non-local field of mind. In this view, our individual consciousnesses are not separate islands, but are rather like whirlpools in a single, vast ocean of psychic energy. The archetypes would be the deep, stable currents in that ocean, shaping the individual whirlpools without being owned by any one of them. This would mean that the collective unconscious isn't just a human phenomenon. It could be a fundamental feature of a conscious, interconnected universe, a domain where minds meet and share a common ground of being beyond the limits of space and time. So, is the collective unconscious a real, tangible domain, or is it merely a useful metaphor for common human experiences? The question remains one of the most fascinating and unresolved in all of psychology and philosophy. From a strictly materialist perspective, these universal patterns could be explained by common evolutionary pressures, the shared challenges of survival, reproduction, and social living that have shaped the human brain for hundreds of thousands of years, creating similar neural architectures that generate similar myths. Yet for many, this reductionist view fails to capture the profound, numinous power that archetypal experiences hold. The feeling of awe when standing before an ancient symbol, the chilling recognition of a dream figure that feels older than history, the sudden insight that connects a personal struggle to a timeless story, these subjective experiences suggest a connection to something far deeper than just neural wiring. They hint at a participatory universe where our inner lives are woven into a larger tapestry of meaning, a shared mind that suggests we are all, in some profound way, dreaming the same dream, and in that dream, discovering the universal themes that make us human. We have spent so much time searching for the secrets of consciousness within the familiar realm of atoms and light, within the world we can see and touch. But what if the true nature of mind is hidden in the deepest, most profound darkness of the cosmos? This brings us to one of the most speculative and spine-tingling ideas at the frontier of science and philosophy, the concept of dark consciousness. We know that the vast majority of the universe, about 95% of it, is made of stuff we cannot see, dark matter and dark energy, an invisible scaffolding and force that shapes the cosmos while remaining utterly elusive to our detection. What if this hidden realm is not just physically dark, but consciously dark? What if dark matter is not inert, but hosts a form of awareness so alien, so fundamentally different from our own, that it is completely beyond our ability to perceive or comprehend? This is not just a wild guess. It is a serious thought experiment that forces us to confront the limits of our understanding and consider that mind might be a more universal phenomenon than we ever dared to imagine. The very nature of dark matter makes this idea both compelling and deeply unsettling. We know dark matter exists because of its gravitational pull. It holds galaxies together and shapes the large-scale structure of the universe. But it does not interact with light or any other part of the electromagnetic spectrum. It simply does not see our world. It passes through our planet, our homes, and our bodies as if we were not even there. Now flip that perspective. If dark matter has its own form of consciousness, it would be a consciousness that is completely oblivious to our entire reality. Our suns, our planets, our cities, and our lives would be as invisible and intangible to it as it is to us. Its experience of the universe would be built entirely through the force of gravity and whatever other unknown interactions govern its domain. Its thoughts, its perceptions, its very mode of being would be built on a physics so foreign that we lack even the language to describe it. It would be an intelligence that is truly, fundamentally other. This radical idea offers a provocative lens through which to view some of our most enduring cosmic mysteries. Take the persistent and perplexing reports of UFOs or UAPs, unidentified aerial phenomena. The official explanations range from secret military technology to atmospheric anomalies, but a small fraction of these incidents defy conventional classification. What if these phenomena are not spacecraft from another star system, but fleeting, accidental manifestations of something far stranger? If a dark matter-based consciousness exists, could it occasionally, and perhaps unintentionally, create gravitational or energetic disturbances that briefly ripple into our visible reality? These manifestations might not be controlled craft, but rather side effects of activity in a parallel reality that shares our space but operates on a different set of physical laws. They would appear to us as impossible physics, sudden accelerations, instantaneous direction changes because they are not operating by our rules at all. They are glitches in the interface between our world and a dark world, moments where the veil between dimensions is momentarily torn. This concept was powerfully and poetically explored in Christopher Nolan's film Interstellar, particularly in the dialogue delivered by actor Matthew McConaughey's character. Reflecting on the nature of love and connection across dimensions, he suggests that some forces we feel might be evidence of realities we cannot yet see or measure. He posits that love isn't just a human emotion, but could be a tangible force, a kind of artifact or signature from a higher dimension that we perceive only dimly. This cinematic metaphor provides a beautiful analogy for dark consciousness. The gravitational pull we attribute to dark matter could be thought of as the love of the cosmos, an invisible, powerful, shaping force that we can measure the effects of but cannot directly see or understand. If that force is accompanied by a form of awareness, then our entire universe is not just filled with invisible matter, but is cradled within an invisible mind, a presence whose intentions and nature are completely unknown to us. To grasp the sheer strangeness of this possibility, we can look to a profound analogy right here on Earth, the deep ocean. For most of human history, the abyssal depths of our own planet were a greater mystery than the moon. We knew the ocean was there, we could see its surface and feel its tides, but the life forms lurking in its perpetual midnight were utterly alien to us. The creatures we have discovered there, like the anglerfish with its bioluminescent lure, or the giant squid with eyes the size of dinner plates, have evolved under crushing pressure, in absolute darkness, sensing their world through sonar, electrical impulses, and sensitivity to water pressure. Their reality is so different from ours that they might as well be living on another planet. A deep-sea creature has no concept of sky, of sun, of birds, or of trees. Its entire universe is the dark, cold water. In the same way, a consciousness based in dark matter would exist in a universe utterly divorced from our own, even though we occupy the exact same space. We are to each other like ghosts passing in the night, each living in a parallel world that the other cannot access. This leads to the most profound and perhaps unanswerable question this theory poses. If such a dark consciousness exists, could we ever hope to communicate with it? The challenge is not merely technological, it is existential. Communication requires a shared language, a common medium through which information can be exchanged. We communicate with light, sound, and touch, all forms of electromagnetic interaction. A dark consciousness, by definition, does not participate in that reality. It might communicate through gravitational waves, or through fluctuations in the density of dark matter, or through some other physics we have not yet discovered. How do you say hello to an entity that cannot see you, hear you, or feel you? Our entire history of contact is based on the assumption that other intelligences will share our fundamental sensory apparatus. This idea shatters that assumption completely. The gap between us might be so vast that even the concept of communication, as we understand it, is meaningless. We might be able to detect the gravitational footprint of its large-scale structures, much like we detect the presence of a deep-sea leviathan by the disturbance it creates in the water, but we would have no way of deciphering its meaning or intent. This incredible unknown does more than just add another bizarre theory to our list. It exponentially expands the potential reach of mind in the cosmos. It suggests that consciousness might not be a rare fluke on a few rocky planets, but a fundamental and pervasive property of the universe that can emerge from any sufficiently complex system, even one made of matter that is invisible to us. It forces a profound humility, reminding us that our current science, for all its power, has only illuminated 5% of the universe's contents. The remaining 95% is a vast, dark ocean of mystery, and within that ocean, entire civilizations of mind could be swirling, thinking, and being in ways we cannot fathom. We are only just beginning to dip our toes into the water, and the depths we have yet to explore promise wonders and terrors beyond our wildest imagination. We often picture time as a relentless, linear river, flowing in one direction from the past through the present and into the future. But what if this river is not a smooth, uniform current? What if it has deep, swirling eddies and quiet, still pools where the normal rules of flow are suspended, creating pockets where past, present, and future mingle and overlap? This beautiful metaphor offers a more fluid and complex vision of time, one that finds surprising support in the twists of Einstein's relativity and the depths of human consciousness, suggesting that our experience of time's arrow might be far more malleable than we think. Within the framework of general relativity, the river metaphor takes on a literal, mathematical dimension. Einstein's equations describe spacetime not as a static stage, but as a dynamic fabric that can be warped and curved by mass and energy. A massive object like a star or a black hole doesn't just create a gravitational pull, it creates a depression in the spacetime fabric, much like a heavy ball placed on a stretched rubber sheet. Now imagine the flow of time as water flowing over this curved landscape. Near the edges of the depression, the water flows normally, but as it gets closer to the massive object, the flow begins to spiral, creating a gravitational eddy. This is the phenomenon of gravitational time dilation, where time itself flows at a slower rate the deeper you are within a gravitational well. Your feet, closer to the Earth, literally age more slowly than your head. This isn't just a theory. It's a measured effect that must be accounted for in the GPS satellites orbiting our planet. Their clocks run faster than those on the ground, and if we didn't constantly correct for this, the entire system would fail within hours. These relativistic eddies are not science fiction. They are a fundamental feature of how our universe operates. proving that the river of time does not have a single, universal speed, but changes its flow depending on where you are and how you are moving. Beyond the cosmic scale, we can experience these temporal eddies in the intimate landscape of our own minds, particularly through deep meditative states. When a seasoned meditator sits in stillness, focusing on the breath and letting go of the endless stream of thoughts, something remarkable can happen. The frantic mental chatter about past regrets and future anxieties begins to quiet. The compulsive need to track the passing of seconds and minutes falls away. In this state of deep presence, time itself seems to change its quality. It may feel as though hours have passed in what the clock says was only a few minutes, or conversely, a single minute of profound stillness can feel like an expansive eternity. This is the mind finding one of time's quiet centers, a still pool in the river where the turbulent flow of linear time settles into a deep, timeless now. It's a state of pure awareness, unburdened by the narrative of past and future, where consciousness touches a reality that exists outside of the clock. This experience suggests that the flow of time is not just an external physical phenomenon, but is also deeply intertwined with our state of awareness and the quality of our attention. Perhaps the most common and universal experience of time's fluidity occurs every night in our dreams. Within the dream world, time becomes a completely elastic and illogical construct. You can instantly transition from one scene to another, from a childhood classroom to a futuristic cityscape, with no journey in between. A dream narrative that feels like it unfolds over an entire day can actually take place in the few minutes of a REM cycle. You can have conversations that last for dream hours, only to wake up and find mere moments have passed. Dreams effortlessly break the rules of cause and effect, allowing the future to influence the past or for multiple timelines to collapse into a single, confusing experience. This is the subconscious mind operating free from the brain's usual timekeeping functions, revealing that our default experience of linear time is a carefully constructed illusion maintained by the waking brain. Dreams show us that our psyche is naturally capable of navigating time's eddies and whirlpools, effortlessly accessing a realm where all moments are potentially available, and the river's current is not a tyrant but a suggestion. All of this invites a deeply personal and reflective question. If time indeed has these quiet centers and fluid dynamics, can we learn to find them more deliberately in our daily lives? Can we step out of the relentless current and rest in a stiller, more peaceful relationship with time? The answer appears to be yes, and it begins with cultivating presence. Practices like mindfulness meditation are essentially training for finding these eddies. By repeatedly bringing our attention back to the present sensation, the feeling of the breath, the sounds in the room, we strengthen the mental muscle needed to resist being swept away by the river's strongest currents. We can also find these moments in states of deep absorption, or flow, when we are so fully engaged in a challenging and rewarding activity that we lose all sense of time passing. In these states, we are not fighting against time. We are harmonizing with its deeper, more complex nature, discovering that within its flow are infinite opportunities to find peace, stillness, and a profound connection to a reality that exists beyond the tick of a clock. What if every thought, every event, and every moment of existence is not lost to the past but is permanently etched into the fabric of the cosmos itself? This is the profound and captivating premise behind the idea of a cosmic memory, a timeless library often referred to as the Akashic Records. Imagine a vast, non-physical repository, an infinite, ever-expanding archive that holds the complete history of the universe, not just in terms of physical events, but every emotion, intention, and thought that has ever occurred. In this view, the past is not gone. It is simply stored on a different frequency of reality, accessible in theory to anyone who can learn to tune their consciousness to the correct wavelength. This concept transforms the universe from a cold, mechanical system into a living, remembering entity, a cosmos that is self-documenting on a scale beyond our comprehension. The term itself, Akasha, finds its roots in ancient Sanskrit, where it translates to mean sky, space, or ether. In Hindu philosophy, it is considered the first element, the primordial substance from which all other elements emerge, a fundamental field that is the carrier of sound, light, and information. The idea was later adopted and popularized in the West by the Theosophical movement in the late 19th and early 20th centuries. Figures like Helena Blavatsky and later Annie Besant and C. W. Leadbeater described the Akashic records as a cosmic chronicle, a sort of divine film upon which all of reality is recorded. But the most famous proponent of this concept in the modern era was undoubtedly the American psychic Edgar Cayce, often called the sleeping prophet. Cayce would enter a trance state and access what he called the Book of Life, providing individuals with astonishingly detailed readings about their past lives, health conditions, and even future potentials, all sourced from this informational field. He described it not as a physical library with books, but as a vibrational record where every soul's journey is imprinted upon the Akasha, the essential medium of the universe. This notion of a universal information field finds a startling and compelling resonance with some of the most cutting-edge theories in theoretical physics. The holographic principle, which we've explored, suggests that all the information describing our three-dimensional reality is actually encoded on a two-dimensional boundary at the edge of the universe. This transforms the cosmos into a phenomenal projection, a cosmic movie where the data for every frame is permanently stored. The Akashic records can be seen as a metaphysical or spiritual interpretation of this same idea, a timeless, non-local storage system that contains the complete data set of existence. Similarly, the concept of quantum memory proposes that information is never truly lost, even when it falls into a black hole, thanks to the laws of quantum mechanics. This principle of conservation of information implies that the past is not erased but preserved in some form. If the universe itself is a quantum system, then the Akashic records could be the ultimate manifestation of this principle, a grand, unified memory bank where the wave function of every event that ever was continues to exist in a state of potential, forever part of the implicate order. Perhaps the most accessible and human evidence offered for this cosmic memory comes from the practice of past life regression therapy. Under hypnosis, individuals have reported vivid, detailed experiences of living in different historical periods, often speaking languages or describing customs they have no conscious knowledge of. While skeptics rightly attribute many of these accounts to cryptomnesia, the subconscious remembering of forgotten books or films, or to the brain's powerful ability to confabulate stories, some cases are deeply puzzling. There are well-documented instances of children spontaneously recalling precise details of a previous life, including names, locations, and specific events, which are later verified by independent investigators. From the perspective of cosmic memory, these regressions are not about a soul literally traveling back in time, but rather about a conscious mind temporarily accessing the Akashic records, tuning into the informational imprint of a specific life that is stored within the universal field. The individual is not remembering their own past, but is reading from the cosmic library, connecting with a record that exists for everyone and everything. This leads us to the most profound and tantalizing question this idea presents. If this universal knowledge exists, could we ever learn to consciously access it? Could we develop the mental and spiritual faculties to become librarians of the cosmos, able to retrieve not just personal past lives, but the wisdom of ancient civilizations, the lost knowledge of Atlantis, or the creative insights of history's greatest minds? The answer, according to mystics and philosophers who have explored this concept, is a resounding yes, but it requires a fundamental shift in how we use our consciousness. Our normal, waking awareness is like a flashlight beam, focused narrowly on the immediate present and our personal concerns. Accessing the Akasha would require us to broaden that beam into a diffuse floodlight, expanding our awareness beyond the ego and its limitations to resonate with the fundamental field of information that underlies reality. This is achieved not through intellectual effort, but through deep states of meditation, profound intuition, or altered states of consciousness where the filters of the brain are temporarily quieted. It is about becoming a clear vessel, allowing universal knowledge to flow through rather than trying to grasp it with the rational mind. This concept of a memory that transcends the individual mind completely revolutionizes our understanding of who we are. It suggests that our brain is not the source of memory, but rather a receiver and interpreter of it. Our personal memories might not be stored in the neural networks of our hippocampus alone, but could be accessed by our brain from the Akashic field, much like a computer accesses data from the cloud. This would explain the elusive nature of memory, why it is so dynamic, why it can be unreliable, and why sometimes a long-forgotten memory can return with perfect clarity in a moment of inspiration. It positions human consciousness not as an isolated phenomenon locked inside our skulls, but as a localized expression of a universal conscious field, intimately connected to the entire history of the cosmos. We are not just beings who have memories, we are beings who participate in and can potentially access the infinite memory of the universe itself, a realization that dissolves the boundary between the personal and the cosmic, revealing that our deepest self is intertwined with the eternal story of all that is. Imagine for a moment that the entire universe is a grand, silent symphony, with every single thing in existence from the smallest atom to the largest galaxy vibrating at its own unique frequency. Now consider the possibility that your consciousness, your very awareness, is not a static entity but a dynamic vibration, a specific resonant frequency that can harmonize or fall out of sync with the world around you. This is the fascinating premise behind the role of resonance in consciousness, a theory that suggests the fundamental connection between all things might be found not in solid matter, but in the invisible, rhythmic dance of vibrations. From the way sound waves can shape sand into intricate patterns to the synchronized brain waves of a deeply connected group, resonance appears to be a powerful, unifying force that orchestrates both the physical world and the inner world of the mind, hinting that we are all participants in a cosmic concert where the music is the vibration of existence itself. We can see the raw, ordering power of vibration demonstrated beautifully in the science of cymatics, the study of visible sound and vibration. When you place a thin layer of sand or particles on a metal plate and play a specific frequency through it, something magical happens. The particles are not scattered randomly, they arrange themselves into stunning, complex geometric patterns. A low frequency might create a simple circle, while a higher, more complex frequency generates intricate mandala-like designs of breathtaking symmetry. This is a direct, visual demonstration that sound, which is simply vibration moving through a medium, has the power to organize matter. It provides a tangible metaphor for how vibrational forces might work on a much grander scale, suggesting that the patterns we see in nature, the spiral of a galaxy, the petals of a flower, the structure of a snowflake, could be the result of stable, resonant frequencies imprinting themselves on the fabric of reality. If sound can create such order in a tray of sand, Could the underlying vibrational field of the universe be responsible for the order we see throughout the cosmos? This idea that everything is in a state of vibration is more than just a poetic notion. It is a cornerstone of modern physics. At the quantum level, atoms are not tiny, solid balls, but are more accurately described as vibrating packets of energy. The chair you are sitting on, the air you are breathing, and the screen you are looking at are all, at their most fundamental level, shimmering fields of energy vibrating at specific frequencies. This has led some theorists to propose that consciousness itself might be a resonance phenomenon. The renowned neuroscientist and psychiatrist Dr. Ian McGilchrist, while not reducing consciousness to mere vibration, has extensively explored how the brain's two hemispheres resonate with the world in different ways, shaping our perception of reality. A more specific theory, pioneered by scientists like Sir Roger Penrose and anesthesiologist Stuart Hameroff, suggests that consciousness arises from quantum vibrations within the microtubules of our brain cells. In this model, our subjective experience is the music produced by the orchestrated vibrational dance of these tiny structures, a symphony of quantum resonance that gives rise to the melody of awareness. If this is true, then your every thought and feeling might be a unique vibrational pattern, a complex chord in the symphony of your mind. The profound connection between vibration and consciousness becomes even more apparent when we examine the electrical activity of the brain itself. Our neurons communicate through rhythmic pulses, creating brain waves that we can measure with an EEG. These waves are categorized by their frequency, and each frequency band is associated with a different state of consciousness. Deep, slow delta waves are present in dreamless sleep, while faster beta waves dominate our waking, analytical thinking. The serene, unified awareness experienced by advanced meditators is often accompanied by highly synchronized gamma waves across the brain. This synchronization is a form of internal resonance where different parts of the brain begin to vibrate in harmony, leading to a state of heightened coherence and peace. It's as if the brain is tuning itself like a musical instrument, and when all the strings are in tune, the result is a state of clarity and integrated consciousness. This isn't just happening inside one skull. There is fascinating research suggesting that when people engage in a shared, focused activity, like singing in a choir, praying together, or even attending a captivating concert, their brain waves can begin to synchronize with each other. This neural entrainment creates a palpable sense of unity and collective emotion, a shared resonant field that transcends individual boundaries and connects the group into a single, harmonious unit. This power of shared resonance is harnessed intentionally in practices like music therapy and collective rituals, which have been used for millennia to heal, unite, and transform human experience. In music therapy, specific sound frequencies and rhythmic patterns are used to help patients with anxiety, depression, and PTSD. A slow, steady drumbeat can guide a frantic heart rate to slow down and match its rhythm, a process known as entrainment. The calming vibrations of a singing bowl or the structured harmonies of a Mozart concerto can help to reorganize disordered brainwave patterns, bringing mental chaos into a more harmonious and peaceful state. Similarly, collective rituals from the rhythmic chanting in a Buddhist temple to the ecstatic dancing of a Sufi ceremony use shared vibration to dissolve the illusion of separation between individuals. The repetitive drumming, singing, and movement create a powerful collective resonance that allows participants to feel part of something larger than themselves, accessing states of joy, transcendence, and community bonding that are difficult to achieve in isolation. These practices demonstrate that resonance is not just a physical principle. It is a bridge between minds, a tool for healing, and a pathway to experiences that feel truly spiritual. All of this evidence, from the patterning of sand to the synchronization of brains, culminates in a truly awe-inspiring question. If we are fundamentally vibrational beings living in a vibrational universe, can we learn to consciously harmonize with the deepest frequencies of the cosmos itself? This is the grand promise behind the idea of cosmic resonance. Throughout history, mystics and sages have spoken of the music of the spheres, the notion that the planets and stars move in harmonic ratios, creating a celestial symphony. Modern science has found an echo of this in the concept of gravitational waves, the ripples in space-time caused by colossal events like colliding black holes, which literally set the fabric of the universe ringing like a bell. The search for a fundamental, unifying vibration, sometimes called the Schumann resonance or theorized in string theory as the vibrations of multidimensional strings, points toward a universe built on a foundation of harmonic principles. The invitation, then, is to see our personal journey of consciousness not as a solitary struggle, but as a process of tuning our internal instrument, our mind and body, to resonate in harmony with this grand cosmic order. By cultivating peace, compassion, and mindfulness, we might be subtly adjusting our vibrational frequency, moving from a state of dissonance and conflict to one of harmony and connection, allowing us to play our part beautifully in the greatest symphony there is. What if the very core of your identity, that unwavering sense of being a single, continuous self, is the greatest illusion of all? We cling to the idea that our consciousness is a singular, unbroken thread winding its way through a single timeline, but what if the truth is far more expansive and strange? The theory of parallel consciousness proposes a breathtaking alternative, that your awareness is not confined to one reality, but is simultaneously experiencing countless versions of your life across an infinite array of branching timelines. In this radical view, you are not just one you are a multitude, a vast collection of conscious experiences all stemming from the same source, yet each living out a different possibility in its own unique world. This idea finds its strongest scientific footing in the many worlds interpretation of quantum mechanics. As we've discussed, this theory suggests that at every moment where a quantum event has multiple possible outcomes, the entire universe splits, creating new branches for each possibility. From the perspective of an outside God-like observer, there is a universe where you turned left this morning and another where you turned right. But the theory of parallel consciousness asks a deeper question. What happens to the subjective experience of the you in each of those branches? Does the original you only experience one path, unaware of the others? Or is there a sense in which your fundamental consciousness is present in all of them simultaneously? This isn't about your memories or your personality, which would understandably diverge in each branch, but about the raw, subjective field of awareness itself. Could it be that the foundational ground of consciousness is non-local, not bound to a single brain in a single universe, and that it simply expresses itself through every possible version of the neural structure that constitutes you? You wouldn't be aware of your other selves for the same reason you aren't aware of the individual neurons firing in your brain. Your conscious experience is the integrated product of the system, not a witness to its countless parts. This concept can feel utterly alien, but we can find a powerful analogy in the world of video games, particularly in narrative-driven games with branching storylines. Think of a game like Detroit Become Human or The Witcher. At key decision points, the player makes a choice, and the story branches off into a new narrative path. From the player's perspective, seated in front of the screen, you are a singular consciousness observing one playthrough, but the game's code contains every possible branch simultaneously. Now, imagine if the character you were controlling, Connor the android or Geralt of Rivia, was itself conscious. In the branch where Connor becomes a deviant, that Connor would have his own stream of experience. In the branch where he remains a machine, that Connor would have a completely different, but equally real, subjective life. The player's singular perspective outside the game is akin to the non-local ground of consciousness, while each character's experience represents a parallel consciousness within a specific timeline. You, as the player, are not any one of them exclusively. You hold the potential for all of them. This analogy helps us conceptualize how one source could give rise to multiple, simultaneous streams of awareness, each isolated from the others yet fundamentally connected at their origin. This inevitably leads us to consider a profound and sensitive parallel in the realm of psychology: dissociative identity disorder, previously known as multiple personality disorder. In this condition, a single individual exhibits two or more distinct personality states, each with its own pattern of perceiving and interacting with the world. These alters can have different memories, mannerisms, and even physiological responses. While the mechanisms are traumatic and psychological in origin, a way for the mind to cope with unbearable stress by compartmentalizing it, the phenomenon presents a fascinating metaphor for parallel consciousness. The human brain, under extreme duress, demonstrates a capacity to host what appear to be multiple concurrent centers of awareness, albeit not always simultaneously active. This isn't to trivialize the disorder by equating it with quantum physics, but rather to point out that the architecture of the human mind already possesses a latent, albeit pathological, ability to fracture a singular sense of self into parallel streams of experience. It suggests that the brain may be a more versatile receiver of consciousness than we realize, capable of tuning into different stations of identity, which in the many worlds interpretation would be the different branches of reality. A new field of study known as quantum psychology has begun to explore these very intersections. It seeks to apply the insights of quantum theory, such as superposition, non-locality, and the observer effect, to model the complexities of the human mind. From this perspective, the constant internal dialogue we all experience, the weighing of options and the entertaining of different possible futures, could be seen as more than just imagination. It might be a psychological reflection of the mind's inherent connection to its parallel existences. That feeling of being of two minds about a decision isn't just a conflict within one brain. It could be a faint, intuitive resonance with the other versions of you who actually made the different choice. Your anxiety about a path not taken or your uncanny certainty about a decision could be interpreted as your consciousness subtly brushing against the experiences of your other selves in the vast probability tree of your life. Quantum psychology doesn't provide easy answers, but it offers a new and richer language to describe the profound mystery of our inner world, framing our mental struggles and triumphs not as isolated events, but as part of a much larger, multi-dimensional tapestry of existence. All of this speculation culminates in a question that is both thrilling and deeply unsettling. If this theory holds any weight, are there other yous out there right now, living the life you didn't choose? Is there a version of you who pursued that dream job, married that other person, or moved to that distant country? And if so, what is the nature of your connection to them? This thought experiment challenges the very foundation of our singularity, our cherished belief in our unique and irreplaceable self. It suggests that our identity is not a fixed point, but a probability wave. Our sense of being a single, continuous self may be a necessary and elegant fiction created by the brain to make sense of its journey along one specific branch of reality, a narrative anchor in a sea of infinite possibilities. This doesn't diminish our lives, it expands their significance infinitely. Every choice becomes monumental, not because it defines the only path, but because it actualizes one thread of a magnificent, multi-dimensional existence where every potential is realized and every version of you is, in its own timeline, living a life that is utterly real and uniquely its own. What if the relentless pressure of time, the weight of past regrets, and the anxiety of future uncertainties could simply melt away, leaving only a profound and peaceful sense of being right here, right now? This is the powerful invitation at the heart of the concept known as the timeless now, a perspective that suggests the present moment is not just a fleeting point between past and future, but the only reality that truly exists. Both ancient spiritual traditions and modern interpretations of physics are converging on this astonishing idea, challenging the tyranny of the clock and offering a pathway to a freer, more authentic way of living. Imagine for a moment that all of time, every event from the dawn of the universe to its farthest potential future, is like a vast, already recorded film. This is the block universe model we've explored, where past, present, and future are equally real and permanently fixed in the four-dimensional fabric of spacetime. From this God's eye view, there is no special now moving forward, every moment just is. The feeling of time passing then is not a property of the universe itself, but a feature of our conscious perception. Our awareness is like a spotlight moving along the world line of our lives, illuminating one moment at a time and creating the powerful, persistent illusion of a flowing present. This physical model dovetails beautifully with the core teachings of mindfulness and presence found in spiritual practices across the globe. The renowned spiritual teacher Eckhart Tolle, in his transformative book The Power of Now, argues that we spend most of our lives trapped in the mind's compulsive focus on the past and future. We relive old hurts and rehearse future conversations, all while missing the only thing that is ever real, this present moment. He writes, "Realize deeply that the present moment is all you ever have. Make the now the primary focus of your life." Tolle isn't just offering philosophical advice. He is pointing to a fundamental shift in consciousness, a waking up from the dream of time into the vivid reality of the eternal present. We don't need to be advanced meditators or physicists to catch glimpses of this timeless reality. We experience it in those precious moments of complete absorption known as flow states. An athlete in the middle of a perfect play, a musician lost in a performance, an artist fully immersed in painting. In these states, something remarkable happens. The internal chatter of the mind ceases, self-consciousness vanishes. There is no past to regret and no future to worry about. There is only the seamless, effortless doing of the activity. In flow, time doesn't just slow down or speed up, it becomes irrelevant. An hour can feel like a minute, and a minute of intense focus can contain a universe of experience. The clock is still ticking in the external world, of course, but subjectively, the individual has stepped out of time's river and into a state of pure being. This is the timeless now, not as a theory, but as a lived experience, a demonstration that our normal, time-bound consciousness is just one mode of operation, and that we can access another where the burden of temporal pressure simply doesn't exist. This leads to perhaps the most practical and profound question we can ask ourselves: can we learn to live permanently from this place of the eternal now? Is it possible to make this our default state of being, rather than a rare and fleeting experience? The answer from those who teach presence is a cautious yes, but it requires a radical reorientation of our attention. It's not about trying to stop time or deny the practical need to learn from the past and plan for the future. Instead, it's about shifting our primary sense of reality from the story our mind tells about time to the direct experience of the moment we are actually in. This means consciously bringing our awareness back again and again to the sensations of the body, the breath moving in and out, the sights and sounds happening right now. Each time we notice our mind has wandered into a memory or a daydream, we gently return to the anchor of the present. This practice, over time, can weaken the habitual pull of time-based thinking and allow the peace and expansiveness of the timeless now to become a more consistent background to our lives. It is the ultimate act of freedom, a liberation from the psychological weight of yesterday and tomorrow, allowing us to meet life as it actually is, not as we fear it was or dread it might be. After exploring the profound depths of timeless awareness and the branching pathways of parallel selves, we arrive at a vista that might just be the ultimate destination of our entire journey, a perspective so unifying it seeks to dissolve the very distinctions we've been exploring. This is the radical proposition that space, time, and consciousness are not three separate things interacting in a cosmic dance, but are instead three inseparable facets of a single, unified whole, a fundamental entity expressing itself in the only ways our limited perception can understand. We have spent centuries in science and philosophy trying to understand how the mind connects to the body, how consciousness arises from matter, and how we exist within space and time. But this idea turns the entire inquiry on its head, suggesting there is no connection to be made because there was never a separation to begin with. The observer, the act of observation, and the stage upon which it all unfolds are, in their essence, one and the same. The brilliant physicist John Archibald Wheeler, a collaborator of Einstein's, pointed toward this breathtaking unity with his concept of the participatory universe. He famously suggested that we are not just passive observers on a pre-existing cosmic stage, but active participants in bringing the universe into being. His dictum, it from bit, proposes that every particle, every field, and every force of nature ultimately derives its existence from the answers to yes or no questions, from bits of information elicited by acts of observation. In this view, the universe is fundamentally an information system, and consciousness is the process that turns that information into experienced reality. There is no external world waiting to be discovered. There is a reality that emerges from the participatory act of questioning and measuring. Wheeler's work implies that the universe only takes on a definite form through the interaction with conscious beings, weaving us into the very fabric of its coming into being. This isn't a minor role for consciousness. It is the central mechanism through which possibility becomes actuality, suggesting that the cosmos and the mind that perceives it are a single, self-actualizing system. This revolutionary thinking from the frontiers of Western science finds a powerful and ancient echo in the wisdom traditions of the East. Advaita Vedanta, a school of Hindu philosophy, teaches the doctrine of non-duality, the understanding that reality is one, and the perception of manyness is an illusion known as Maya. Brahman is the term for this ultimate, unchanging reality, an infinite, impersonal consciousness that is the source and substance of all that exists. The world of forms, of space and time and individual objects, is not separate from Brahman but is its manifestation, much like waves are not separate from the ocean. Your true self, or Atman, is not a tiny consciousness inside your head, but is this universal consciousness itself, temporarily experiencing the drama of separation. Similarly, in Zen Buddhism, practitioners seek a direct, non-intellectual realization of this unity, often through koans designed to shatter the dualistic mind. The famous question, "What is the sound of one hand clapping?" is not a riddle to be solved logically, but an invitation to experience a reality where the subject who hears and the object that is heard are revealed as a single, undivided event. These philosophies have pointed for millennia to the fundamental oneness of experience and experiencer, a truth that modern physics is now approaching from an entirely different angle. The holy grail of modern physics, a unified field theory or a theory of everything, represents the ultimate scientific expression of this drive toward unity. The goal is to find a single, elegant mathematical framework from which all the forces of nature, gravity, electromagnetism, and the nuclear forces can be derived. Einstein spent the latter half of his life searching for this unified field. While a complete theory remains elusive, contenders like string theory and loop quantum gravity are profound attempts to describe all of reality as the vibrational patterns or the weave of a single fundamental entity. In these theories, what we perceive as separate particles and forces are just different notes on the same vibrating string, or different knots in the same fabric of spacetime. The tantalizing next step, which some physicists and philosophers are now considering, is whether consciousness itself could be incorporated into this ultimate unification. Could the field of consciousness be the fundamental field, and the physical laws we observe be the patterns that emerge within it? If so, then the search for a unified field theory is unknowingly the search for a complete description of mind itself, finally resolving the ancient Cartesian split between the thinker and the thought, the observer and the observed. But how could such an abstract, metaphysical idea ever be tested or experienced? While we cannot put the entire universe in a lab, we can look for signatures of this unity in the nature of reality itself. The phenomenon of quantum entanglement, where particles remain connected across vast distances, instantaneously influencing each other, is a powerful clue. It suggests that at its most fundamental level, the universe is non-local, that separation is an illusion. This is exactly what we would expect if space itself is not a primary reality, but an emergent property of a deeper, unified field. Furthermore, the very act of scientific measurement supports this view. In quantum mechanics, the observer is inextricably linked to the outcome of an experiment, not as a passive witness but as an integral part of the system. This is not a flaw in the theory, it is a feature of reality pointing toward Wheeler's participatory principle. On a personal level, this unity is not something to be proven intellectually, but to be realized experientially. In deep states of meditation, mystical experience, or even moments of profound awe in nature, the sense of a separate self can dissolve, replaced by a direct feeling of being one with the environment, with the cosmos, with existence itself. In these moments, the conceptual boundaries of space and time fall away, and what remains is a pure, undifferentiated awareness that is both the subject and the object of its own experience. This brings us to the final, culminating question of our entire exploration. Is reality a single, unified entity simply wearing many different masks? Does the cosmos, with its billions of galaxies, its infinite diversity of life, and its vast stretches of time, have one face beneath all its appearances? The theory of holism answers with a resounding yes. Holism is the idea that systems and their properties should be viewed as wholes, not just as collections of parts. The whole is greater than the sum of its parts because the relationships and interactions between the parts give rise to emergent properties that cannot be predicted or understood by studying the parts in isolation. The wetness of water cannot be found in a single hydrogen or oxygen atom. It emerges from their relationship. In the same way, the universe itself might be the ultimate holistic system. Space, time, matter, energy, and consciousness are not Lego blocks that can be understood separately and then snapped together. They are interdependent aspects of a single, seamless whole. This perspective does not destroy the rich diversity of the world. It celebrates it as the magnificent and varied expression of a unified source. It resolves the nagging dualities that have perplexed us for centuries: mind versus matter, subject versus object, us versus the universe, not by choosing one side over the other, but by revealing that the duality itself was the illusion, a trick of perception that fades when we finally see the whole picture. And so our extraordinary journey through these 40 mind-expanding theories draws to a close. Yet in many ways, this is not an ending but a new beginning, an invitation to see the universe and your place within it through an entirely new lens. We have ventured from the smallest quantum vibrations to the vast expanse of cosmic consciousness, exploring ideas that stretch the very fabric of what we believe is possible. We have considered time not as a river but as an ocean, space not as emptiness but as a vibrant field, and consciousness not as a lonely accident but as the fundamental ground of all being. These are not merely abstract speculations for physicists and philosophers in ivory towers. They are profound invitations for each of us to participate in one of the most exciting conversations of our time, a dialogue that is reshaping our understanding of reality itself. What makes these theories so powerful is that they live in that beautiful space between established science and visionary imagination. They are not wild guesses, but logical extensions of our most successful scientific models: quantum mechanics, relativity, cosmology, pushed to their most astonishing conclusions. They represent the leading edge of human curiosity, where the known world dissolves into a frontier of breathtaking possibilities. This is how science truly evolves, not by accepting the current map of reality, but by daring to explore the territories that lie beyond its edges. Each of these theories, from the holographic principle to biocentrism, from the simulation hypothesis to the concept of a conscious cosmos, challenges us to think bigger, to question our most basic assumptions, and to embrace the beautiful mystery that lies at the heart of existence. This journey is far more than an intellectual exercise. It has profound implications for our personal lives and our collective future. When we internalize the idea that consciousness might be fundamental, it transforms our relationship with ourselves and the world around us. It suggests that our thoughts, intentions, and awareness are not insignificant byproducts of a meaningless universe, but active participants in the ongoing creation of reality. Understanding the potential of a multiverse or the illusion of a linear timeline can liberate us from the weight of regret and the anxiety of the future, allowing us to focus our power on the only moment we ever truly have, the eternal now. These concepts empower us to live with more wonder, more compassion, and a deeper sense of connection to the incredible cosmos we call home. We have explored territories that were once the sole domain of science fiction, but are now the subject of serious scientific papers and spirited debates at the world's most prestigious institutions. The line between physics and philosophy has become beautifully blurred, and that is exactly where the most exciting discoveries are born. This is not a sign of confusion, but a sign of progress, a recognition that to understand the universe, we must also strive to understand the mind that perceives it. The greatest scientific revolution awaiting us may not be the discovery of a new particle, but the final reconciliation of the objective and the subjective, the outer world of matter and the inner world of meaning. As you step away from this exploration, I encourage you to carry these questions with you. Let them simmer in the back of your mind as you look up at the night sky or pause in a moment of quiet reflection. How does the possibility of a holographic universe change the way you perceive the solidity of the world around you? Does the idea of a participatory cosmos influence how you approach your daily actions and intentions? There are no final answers here, only ever-deepening questions, and the shared joy of asking them together is what pushes the boundaries of human understanding. This conversation is just beginning, and your perspective is a vital part of it. I would love to hear which of these theories resonated most deeply with you, or which one you find the most challenging to accept. Share your thoughts and questions in the comments below. Let's continue to explore and learn from each other. If this journey into the unknown has sparked a new sense of wonder and curiosity for you, consider subscribing to the channel so you don't miss our next adventure into the mysteries of science, consciousness, and the cosmos. Thank you for your time, your curiosity, and your courageous spirit. This is not a farewell, but a see you later, as we continue to explore the infinite possibilities